ऐसा रखेंगे, ये ऑब्स्ट्रक्ट कर रहा है विजन।
Okay.
A very good afternoon to one and all present here. We are gathered here on a bright and sunny day, having clear sky with an aim to engage you all for an informative and inclusive seminar conducted by the Indian Coast Guard on topic Transformation of Maritime Aviation by Adopting Technological Trends and Indigenization. We have a fantastic lineup of eloquent speakers who will be sharing their knowledge, insights, efforts, and experiences with us. I request everyone to kindly switch off their mobile phones or keep them in silent mode. Thank you.
On behalf of Indian Coast Guard, we'd like to extend a very warm welcome to the august gathering of dignitaries from various organizations, officials of the armed forces, our esteemed faculty from educational institutions, and my young energetic students. I, Deputy Commandant Mohsin Abbas,
And I, Assistant Commandant Farah TP,
are your host for today's thought-provoking seminar.
A quick walk through the course of events. The seminar will commence with an address by our Honorable Chief Guest, setting the stage for a series of insightful presentations by our distinguished speakers. Today's presentation begins with Shri Aziz P., who will discuss the development of an anti-drone system for protecting Indian Coast Guard maritime assets, followed by Dr. S.N. Omkar, who will shed light on the application of artificial intelligence in maritime reconnaissance and security. Next, Commandant J.G. Narendran R. and Group Captain Abhay C. Deshpande retired will present on transforming the vintage Indian Coast Guard Dornier workhorse into a technologically advanced Indian Coast Guard maritime asset. Lastly, Dr. R. Rajesh will share insights on indigenized technological tools for enhancing maritime reconnaissance.
Each presentation will be followed by an interactive question and answer session, allowing the audience to engage with the speakers, after which the respective speaker will be felicitated. Following the presentations, an engaging panel discussion on challenges in indigenization and resolution is scheduled. The moderator and panelists will then be felicitated in recognition of their valuable contributions, followed by a closing address by Coast Guard Commander Western Seaboard. To formally conclude the event, a group photograph will be taken, thereafter distribution of exquisite souvenirs to all attendees. The seminar will then draw to a close with refreshment for all delegates and participants.
With this seminar, we hope to provide our vibrant audience an excellent opportunity to interact with domain experts and receive valuable insights on emerging trends in the field. We also take this opportunity to welcome our friends in the media for their presence. Ladies and gentlemen, we would also like to bring to your kind attention that Sri Sanjay Seth, Honorable Raksha Rajya Mantri, has graciously consented to be the chief guest of today's seminar. However, due to his busy schedule, he will be joining us later at a convenient time. He has assured us of his presence, and we eagerly look forward to welcoming him.
In light of this, we request all attendees to be mindful that when Honorable Raksha Rajya Mantri arrives, the ongoing session will be momentarily paused. We request everyone to kindly rise to welcome him. The session will resume immediately after his felicitation and address. Now, we are awaiting the arrival of Commander Coast Guard Region Northwest. Ladies and gentlemen, we have amongst us Additional Director General Anil Kumar Harbora, President Tatrakshak Medal, Coast Guard Commander, Western Seaboard. We are also graced by the presence of Inspector General T. Shashi Kumar, Tatrakshak Medal, Commander, Coast Guard Region, Northwest. अंतर्दृष्टि समुद्रदेशु सुरक्षाय समुत्तमा वयम रक्षामा समुद्रम भारतस्य धनुष्याम्बि. With unwavering vision over the oceans, we stand as the finest guardians of security. We protect the seas unwaveringly, armed with indomitable strength of India's might. The Sanskrit shlok elucidates unequivocally the importance of the task at hand, the protection of our nation's water.
Ladies and gentlemen, Indian Coast Guard stand tall in the Indian search and rescue region, ready to support the national maritime objective and offers itself as a contributor to the greater regional matrix. Since inception, we have undertaken more than 4,000 search and rescue missions, around 475 medical evacuations, and saved close to 14,000 lives, which translate to one life every second day. I would also like to mention that we have apprehended narcotic contraband worth approximately 15,000 crores. This information alone demonstrates our commitment to the task at hand.
Ladies and gentlemen, it's an absolute privilege to have amidst us a visionary in maritime security, Additional Director General Anil Kumar Harbora, President Tatrakshak Medal, Coast Guard Commander, Western Seaboard. The flag officer joined Indian Coast Guard in January 1989 as a direct entry officer. A silver medalist in physics from Kumaon University, Nainital, he also holds master degree in management studies from Osmania University, in security and strategic studies from Madras University, and PG diploma in educational administration and supervision from Annamalai University. He is specialized naval communicator and has served approximately 16 years in seagoing appointments. The flag officer has commanded all types of Coast Guard ships, including hovercraft. In 1999, the officer, while commanding Coast Guard ship Tarabai, apprehended hijacked Japanese merchant vessel Alendra Rainbow, along with hijackers, after a chase for almost 750 kilometers in Arabian Sea, and was awarded Tatrakshak Medal for gallantry by Honorable President of India for the same. He has also been awarded the President Tatrakshak Medal for distinguished service on 26 January 2025. The flag officer has been commended by the Director General of the Indian Coast Guard. During his tenure as COMCG Northwest, narcotics worth 3,015 crore was apprehended along with 211 intruders. The officer is an alumnus of U.S. Coast Guard International Maritime Officers School in Yorktown, Virginia, College of Defense Management, Secunderabad, and that of National Defense College, New Delhi. He is also a qualified interviewing officer from Defense Institute of Physical Research, New Delhi. Currently, the flag officer is pursuing PhD in Maritime Affairs from Rashtriya Raksha University, Gandhinagar. On that note, we now proceed with our seminar, as we look forward to the arrival of our Honorable Raksha Rajya Mantri later in the session.
Ladies and gentlemen, we would now commence our presentation session. Our first speaker, Shri Aziz P., is a BTech in Electronics and Communication Engineering from Government Engineering College, Kannur, under University of Calicut, and MTech from Indian Institute of Science, Bengaluru. He joined Electronics and Radar Development Establishment, DRDO, Bengaluru, as a scientist in 2000. As the project director, he has successfully completed the development of rotating, multifunction, active phase array radar named Air Defense Tactical Control Radar. Currently, he is working as Scientist G and is the project director of Project D4 for development of counter-drone system in DRDO.
In line with the theme for today's first presentation, Shri Aziz P. would be enlightening us with the development of anti-drone system for protecting Indian Coast Guard maritime assets. I would like to invite Shri Aziz P. to deliver his presentation.
Thank you, and good afternoon, everyone. Drones have become a threat in the recent past, maybe last 2-3 years. The drone in warfare, drones become a more important or more importantly spoken topic because of its specific properties. Unlike conventional war, where we have a fighter aircraft systems, missile systems, drones are easy to procure, easy to operate, easily available, and low cost. So in a war scenario, the drone warfare becomes a much more important and major threat. Due to this reason, we have to go for anti-drone systems which will be able to detect, deter or distract the drones. So when we go for counter-drone system, we have to detect the presence of drone in the area. We can go for different methods for detection. We have radar systems, we have electro-optic systems, we can go for passive detection systems, which is like RF detection systems are available. We have acoustic sensor for drone detection. These are all methods for detection of drones. Now what happens is, unlike conventional detection systems or radar systems, due to the peculiar presence of drone, the size is very small, the RCS, radar cross section, is very small. Is it very difficult to detect the drone's presence? Because of that, the conventional methods of detection of aircrafts will not work for drone detection. That is why we go for specific techniques and specific methods for drone identification and detection. Once we detect the drone, we have to ensure drone is identified. The birds and drones are usually going for a common, they have common, we go for, when we see birds and drones, the size is same, the speed is same. Because of that, it will be difficult to identify between drone and birds. Once we get drones identified, we can go for electro-optic systems for drone identification. We can go for RF communication identification, protocol analysis systems are available for drone identification. Once we identify the drones, we have to go for neutralization of drones. We can go for jamming. We can go for jamming. We can go for GPS spoofing. We can go for laser weapons to destroy the drones. We can go for high-power microwaves to kill the drones. These are different technologies available for drone neutralization. Coming to DRDO developed drone. DRDO is working on various technologies for various armed forces and MH agencies. DRDO's counter-drone system has multiple components. One is basically the drone tracking radar, then RF detection and direction finding system. We have electro-optic tracking system for visual identification of the drone. We have soft kill for RF jamming, GPS jamming and GPS spoofing. We have hard kill system for killing the drone, physical destruction of drones using high power laser weapons. These are all the components in the anti-drone system. These all are integrated through a single integrated command and control center. This is how anti-drone system of DRDO is configured. We have a control center where the radar data will be available. The operator will be knowing the presence of drone. This information can be passed to a electro-optic system. We can go for identification of the drone using cameras. Electro-optic and CCTV cameras are available for drone identification. Then once we identify the drone, we can go for activation of neutralization systems against the drone. These two are major techniques are for either you jam the drone's communication or GPS of the drone. Then laser weapon is for physical destruction where we are pumping high power laser energy against the drone. The functions of anti-drone system are listed here. We have the detection of, first will be the primary sensor will be the radar system which will do the detection of the drone using a radar system. It will be maybe within a circle of 10 kilometer radius it will be able to detect the drones in 360 degree. This information will be available in the command center. The parallelly RF detection system will be able to identify the communication signals of the drone and identify that it is coming from a drone. Based on that, this information we can cue the target, cue the drone, identify the target so that electro-optic system and laser weapon will be able to slew towards that and lock on the target. Once that is done and once the target is identified on the electro-optic system and we verify that it is a drone to be engaged, we can go for activation of neutralization systems. The radar system is shown here. This is an active phased array radar with a rotating feature. We can go for rotating as well as non-rotating configuration in this radar. Then this has a range coverage of beyond 10 kilometer depending on the size of the drone. The azimuth coverage is around 360 degree Y by rotation, and if it is non-rotating, this will be a sector coverage. We can go for tracking of multiple drones. Since it is a rotating system, it will be able to track the targets from all 360 directions. Then this information can be provided to a control and command center. Electro-optic tracking system has CCTV and infrared camera systems. This can go up to 5+ kilometers for a standard target. Again, with this is the slowable system which will be able to identify and detect targets from all directions. These are the specifications of the electro-optic system where the field of view information is provided here. This can go for, again, the camera also has a similar specification where we go for, depending on the field of view, the range of the detection will be decided. RF detection is basically when drone is traveling, it will be communicating with the operator through high frequency communication channels. This signal can be intercepted by a system which will be able to identify the communication protocol of the drone, by which it will be able to identify the drone also. This will have drone's information, whatever information drone is sending to the operator, which will be consisting even the serial number or model and make of the drone. Those information can be available through this snooping system. So by that way we will be able to get where the drone is and what type of drone it is. And this is effective especially if drone is not an autonomous mode where it is communicating continuously with the operator. Once the drone is confirmed and identified, we can go for jamming of the system. We can go for, once we know the frequency of the drone, we can go for jamming of that particular frequency. In case that frequency is not known, we can go for wideband jamming where it will be able to jam all the wideband frequencies up to few gigahertz. That's how the jamming operation happens. And this can jam multiple drones can be jammed simultaneously, multiple frequencies can be jammed simultaneously. And if you have a specific requirement of not jamming a specific frequency, that also can be selected. So we'll be able to select all frequency jam or specific frequency jam. That feature also is added in this. Laser system is a high power directed energy weapon where a high power laser beam will be pinpointed to the drone. How it happens is this will have a limited range of operation. Once the drone threat is beyond the level set by the for a critical threat level, we can go for killing the drone, where the very high energy, high power energy will be pinpointed to a spot on the drone, specifically on a smooth portion on the drone, where it will generate kinetic thermal energy will be created. Drone will physically burn by using this laser system. The whole system is integrated through an integrated command and control center, where the operator will be able to get all the information about the drone, the radar display, electro-optic display, jammers display, all this information will be projected on a common integrated system. So once the drone presence is seen, operator will be able to transfer the drone's data to a electro-optic system, which will slew there. It will do the identification. We can do panning and zooming of the camera. Once the camera says that, once we get confirmation that it's a drone, we can go for jamming operation. That screen also is available here. So the complete control and monitoring of the scenario will be done through a control center. This is how we have configured the system. There are various this is for a varied spectrum of users, because the drone anti-drone requirement is coming from various circles and various agencies. So we have to go for different type of configuration. We have gone for a static configuration, where these 3 independent systems will be separately carried in a packing boxes, and it can be installed in a matter of few hours. And second operation is where, second configuration is where we can go for a vehicle-based configuration. We have configured both on 4x4 and 6x6 vehicles. This is based on, again, requirement of users, where all the shelter, operating control center, everything will be inside the single vehicle. Currently, we have transferred the technology. Initial tests are over and development trials are completed. The technology is already transferred to the production agency. Multiple requirements are coming from all services, and the production agency has already started delivering the drones, the anti-drone systems to all 3 services. Plus, considering the future huge requirement of production, we have transferred the technology to multiple industries, private industries. The technology transfer is in progress for that. Now, we have deployed the system for major national events in the country, where VIP functions and all, we have to protect the VIP area, plus we have to protect the area against the presence of drones. So most of the national important functions, we are deploying the systems. In addition, we have tested the system in the border area also against the incoming drone threats, where we got satisfactory results. Now, I have told about the basic drone detection system, where we have a basic radar for detection, camera system for identification, and a laser weapon for destruction, and a jammer system for neutralization. In addition, multiple anti-drone technologies are under development. One of them is a killer drone system, where when we can go for, we cannot go, there are some conditions where we cannot go for jamming in all scenarios, because when we jam a frequency, everything in that area, in that frequency will be jammed again. So there will be collateral issues with that. Just to avoid that, we can go for killer drone system is one technology where against the incoming drone, we can go send another drone towards the incoming drone and go for a direct hit. This is like a kamikaze type of killing. This is one technology under development, and initial trials are completed. Another one is high-power microwave, where instead of laser or jammer, we can create very high energy electromagnetic signal, which will be able to momentarily kill the drone. It is not a direct destruction, it will be rather a soft kill, where the drone's internal circuit will be disabled, which will incapacitate the whole drone operation. Swarm drone is another threat, where when we have multiple drones coming towards a specific area, most of the systems will be able to do operation of one drone at a time, or few drones at a time. When we have an attack coming from all directions, we have to go for some other solution. One is omnidirectional jamming where 360-degree jamming will be possible. Second method is where we can go for swarm drone. Again, it is a kinetic kill where multiple drones can be engaged against incoming multiple swarm of drones by through a technology of algorithm technology. We will be able to engage one drone against another drone. This is one technology which is under development. Here I will stop. Any specific questions I can take now? Sir.
Anybody? What happens at sea when you are operating in a different environment where, the extra pressures are also there on the decision maker, I'll rather say. So 10 kilometers you pick up and you have to do either a soft kill or hard kill, depends on the situation. How much is time available and where do you fit these radar antennas and that operating system, that display? Whoever is supposed to be deciding, okay, kill it, soft kill it, leave it. It can be a foe drone, it can be a friendly drone also, because the environment now, a lot of agencies are there, particularly at sea, we and Navy both are there. And we all are operating different drones. So how much is the time available and what is the convenience of the decision maker available to him? That is my basic question.
When we talk about anti-drone systems, sir, we are mainly keeping in mind small drones, which are in nano and micro category. Drones are having a varied spectrum. It can go from very large size, 2 meter, 3 meter size, to a few centimeter size. So when we are talking about very large drones, conventional system only is the option for killing them. Either it is like an aircraft. So its tracking system also should be conventional radars. Its anti-drone system also should be conventional weapons. If you have a drone which is coming towards you from 100 kilometer, 200 kilometer away, we will not be able to engage that type of drones with these systems. Now, when we talk about anti-drone system, what we are keeping in mind is the targets which are small size, whose effective operational range will be small. So we don't expect that this type of drones will have a destruction or threat range of more than few kilometers. If we have 10 is a massive, big range for large range rather for this type of system, sir, because when we talk about the drones of like Phantom type of drone, Phantom 4 type of drones or surveillance drones, or some small drones which will be able to do some small size weapons. In those type of systems, with these systems will be effective. So our operational range and destruction range also is meant keeping in mind that we are thinking of drones which are less than 10 kilometer threat.
Excuse me?
You've primarily spoken about anti-drone systems which operate over land. So if such systems are required to be fitted on a floating platform, is it going to be gyro-stabilized? It needs some stability because the ship will roll, pitch. It will not be on a horizontal plane. So are you capable of, or have you already developed a system which can be fitted on board a ship which is not going to be stable?
Ship-mounted system is under development now. What we need at the end will be a gyro-stabilized system which will be able to take ship motion compensation. Barring that, overall system configuration electronics will remain same. I have shown two configurations where we have made the same system on either rooftop configuration or tripod configuration or vehicle mounted configuration. Mechanically, configuration only will change. Electronics part, everything will remain same. We can integrate ship's motion sensors with this system so that the pitch roll compensation can be taken care. Once that gyro stabilization is done, remaining will take care, remaining requirement will be same, one part. Second thing, sir, is in this, we are keeping a much wider beam width for the jamming and other systems, so that it will be able to take care of minor deviations in the elevation azimuth planes. That way we can take care of that.
Dr. Aziz, firstly, I'd like to thank you for educating us. My point is, on a small platform, ships are generally 100 meters, 200 meters. maximum aircraft carrier is 700-800 meters. When we put a jammer there, will it affect our own internal system, we are transmitting in sense of radar, we are transmitting in sense of communication equipment. So how much effect it will have on our own radar, because you are also using a radar. You are using a radar, whether that will affect my own pickup of contacts?
I will answer, sir. Most of the drones, what is commercially available, operate on ISM frequencies, which are all free license band frequencies. So all the communication systems being used by services or other agencies will be non-licensed spectrums. So if somebody decides to develop a drone, at the end it is a technology. If somebody can develop a drone which is operating in a frequency which you are using or some other communication system is using, when we are jamming, that also will get affected. But the chance of that is very less for two reasons. It is not easy to develop that type of frequencies which is not easily available, it is unlaced frequencies rather. That is one part. Second thing what happens is we have option to go for specific frequency operation. Suppose you say I have this particular frequency in my communication system, don't touch it. We can ensure that that frequency is never jammed. In our jamming signal, that frequency can be disabled. But situation is when if drone is appearing in that frequency, we have no way to jam it, because if you are jamming that frequency, everything in that frequency will get jammed. Not only drone, everything in that frequency angle cone will be jammed. So we can do maybe some demo we can carry out whether any of the systems are getting affected. We did that experience for a specific requirement where we operated our complete system in full load and ensured that none of the communication equipments were getting disturbed in normal operational sequence.
So do you think that the person operating the drone will use the same frequency at which you are operating your system, so that once you jam that frequency, your own system also gets?
Technically, yes, because if any drone can use some specific frequency, anybody can use another frequency for the same operation. It's like we are using maybe some 800 megahertz for our commercial cell systems, telephone systems. Somebody can operate a jammer, create a jammer in that, and he can jam it. Somebody can use any of the frequencies for any communication equipment if he has a sufficient technology. But it is not commercially available, it is an illegal activity. Once that illegal thing is taken, but we have no other solution there. It will be happening.
I'm sorry for interrupting. Actually, time is never on our side. So I would request to, in case they got a few questions, that can be subsequently taken up. We can proceed further to the proceedings.
Thank you.
Thank you, sir, for your insightful and informative presentation. Now, I would request Deputy Inspector General Jamal Taha, the Rakshak Medal, Deputy Director General Aviation, to please come up on the stage to kindly present a token of gratitude to Shri Aziz P. Sir, please. Thank you, sir.
Introducing our next speaker, Dr. S.N. Omkar is Distinguished Chief Research Scientist at the Department of Aerospace Engineering, Indian Institute of Science, Bengaluru, and an honorary professor in yoga at Vedic Wellness University. He serves as the chairperson of the Standardization of Drones Committee and the convener of the Agriculture Drones Special Committee under the Bureau of Indian Standards. He is a recipient of Karnataka State Rajyotsava Award and the Satish Dhawan Lifetime Achievement Award for Image Processing.
It goes without saying that the speaker's knowledge and experience in application of artificial intelligence in maritime reconnaissance and security makes him an invaluable asset. Now, I would thus like to invite Dr. S.N. Omkar to deliver his presentation.
Namaste. I'll be making a brief presentation about the most talked technologies of the day, the drones, AI, 6G. And towards the end of the presentation, I will also make a presentation of some of the work that we are doing in the related area. So, you know that coastal line is quite strong and wide. I think it is about 7,500 kilometers in our country, more than that little bit. And yes, it is a very humongous task to guard. Therefore, from this podium, I salute to all of you for doing this human service. Next slide, please. Oh, here it is. Thanks. Okay, so apart from that, even from the business perspective, see, we hold a lot of value for anyone who actually would take up this as a business venture also in terms of developing technologies. These are all from the published data. The global maritime security market is ever growing with a CAGR of about 4.5%. And in 2023, well, these are other things that we need to keep in mind, that the maritime industry experienced significant cyber attacks with ransomware and distributed denial of service attacks, which are most predominant. Therefore, while we develop these technologies, we should be aware of some of these impending new threats that could affect. And if you look at the drone market itself, I mean, overall defense-related market, that is also a very promising one, and with a CAGR of 7.8% is the prediction. But again, accompanying threats, as we have always been talking, as the previous speaker also addressed, the commercial maritime sector faces unprecedented security challenges as drone attacks intensify, and particularly in the Red Sea region, they have observed maximum drone attacks. So looking at the applications of UAVs in the maritime defense, first is the intelligence, surveillance and reconnaissance, which I think many are already working. And the most needed is, of course, the search and rescue operations, assisting in locating distressed vessels and individuals with advanced sensors. Then maritime patrol and border security, which is to be automated in some sense, monitoring coastal regions to prevent illegal activities such as smuggling, and if this activity detection can be automated, that is one of the crucial concerns. You may have all types of video analytics, but how do we use some of the technological advancements, especially in AI? So if you look at also the surface vehicles, of course, the left side, I am also trying to put some pictures of some indigenous developments in the country. You can read along, but the surface vehicles, uninhabited, we will use the word uninhabited instead of unmanned to prevent the gender bias. So uninhabited surface vehicles, one is the mine countermeasures, safely detecting and neutralizing naval mines. Then when it comes to anti-submarine warfare, equipped with sonar systems to track and monitor the submarine activities. Then maritime surveillance, conducting persistent surveillance missions and especially providing real-time data, and if possible, making it automated through some of the deep learning techniques is what is needed. If you look at the challenges, one is the environmental challenge, another is security and regulatory challenges, because our country, if you look at the demographic model, it's very complex. We have all the way from sea level to about 4,000 meters high, where we have to operate, temperatures plus minus, I think, 50 degrees centigrade, and the population density is very high. Therefore, we see even today, for example, I happen to chair the drone standardization in the country. We have not been able to actually process this whole concept of BVLOS because there are a lot of other challenges which in other countries it is not that much. Then we do have technical and operational challenges. We will see them in little bit detail. One is the environmental challenges, adverse weather conditions, high winds. For example, today you take any drones, how much gusts and wind conditions they can take, heavy precipitation, then fog, these things can impair operations. And any such devices which are highly environmental dependent would be some sort of impediment in the applications. Sea state variability, changing sea states that affect the stability and navigation of the, if you look at the surface vehicles. Then saltwater corrosion, prolonged exposure. For example, most of these equipment, they have motors, etc., and other components. How do you prevent, how do you make them corrosion resistant? Because in any of these devices that you take, which have rotary movements, the depreciation costs are invariably very, very high. Coming to these regulatory challenges, detection and countermeasures, both applies to the flying and the surface vehicles. Today, the speeds are very, very fast. I think that was one of the questions, how much time it would take, because even if you detect at 10 kilometers, you don't really have too much of time at your disposal. Your reaction time has to be very, very fast, because things have improved. Because if you take the fixed wing also, we have already clocked 900 kilometers per hour. So you can imagine, even if you detect that, considering the distance, the reaction times required are very, very important. Then regulatory compliance, especially when it comes to the maritime, a lot of international borders you encounter. Now, what is the policy there? How much you can take? What are the regulatory policies between the two countries, etc., need to be looked at. Then most importantly, cyber security threats. Because cyber security today, well addressed in case of banks, not though foolproof, but yet when it comes to drones, etc., it is still a very, very challenging thing. For your information, we have just published on BIS website the cyber security standards as applied to unmanned aerial vehicles. You can all go through that, and what in that we can take, because this would involve more than just, because that we have done mostly for the civilian applications, but when it comes to the military and especially when it comes to the maritime applications, I think a lot more need to be looked at. Technological and operational challenges. One is the communication interference. The surface vehicles often encounter challenges such as communication interference, dynamic obstacles, because you could have other vehicles moving that detect and avoid, and with proper communication is essential. Then both UAVs and USVs face constraints with respect to the power supply, limiting their operational range and duration, which is very, very critical. Navigation and collision avoidance. This is one of the most important things. How do we handle this? Of course, we have been developing a lot of algorithms. In fact, in our lab, and my colleague Professor Suresh is there. Our labs have been working on how to handle these both for surface vehicles and aerial vehicles. So this is where, because of the increased number of these kind of vehicles, you have helicopters, aircrafts, you have ships, other boats, so many things, then this traffic management becomes a critical issue. So this so-called UTM, or the uninhabited traffic management, becomes very important. This ecosystem is separate from but complementary to traditional ATMs. We should remember that. And because of the growing applications of UAVs, now we are talking of an integrated airspace. There is no separate thing possible just for ATM and drone, because drone space is also growing in a very, very significant way. The purpose is, of course, enabling management of low altitude drone operations as well as high altitude. Then relevance is essential for coordinating maritime UAV operations and ensuring regulatory compliance. The challenges, obviously, the connectivity limitations, especially when you go into the sea environments, robust network infrastructure, etc. Even on terrestrial, we see that many places the networks are not that easily accessible. High latency and data delays. Today, even with the modern 5G, the latency is quite a matter for communication and decision making. Then there are regulatory gaps. Standardized global framework, especially for maritime UAV traffic, to the best of my knowledge, is still in the nascent stage. So this is what we foresee. You definitely need a AI-powered traffic flow management, because we need intelligence on board of even the vehicles. The simplest reason is we cannot just presume everything in the ab initio, because this is a very dynamic environment. For example, even if you take the drone traffic on the terrestrial sense itself, even if you set some protocol, suddenly if there is a medical drone that is coming, futuristic, then that has to obviously take precedence over other drones. Now, how do you dynamically change, and how do you create proper drone corridors, and how do you create a decentralized UTM model, because it cannot be centralized. As on the move, things should be able to happen. That's where the blockchain and AI-driven systems are very, very important. Then integration with non-terrestrial networks. With the advent of 6G, I'm sure it is going to happen, because we really can't completely depend on the terrestrial network that is there. So SATCOMs are really essential. Well, 6G is already we have been talking about, a lot of experiments is happening, and its role is ultra high speed, then sub-millisecond latency, because now with the current networks, it is about 5 milliseconds. That is not really sufficient. Then AI-driven optimization, especially with the advances in machine learning. But there also there are certain topics to be discussed, which I'll highlight, because the moment you say machine learning, the models are quite heavy. And if you want to put it on a flying vehicle in particular, because one is the power. They are all power guzzlers. We need to be mindful about the power consumption and how do we optimize that. So key benefits, scalability with 6G is a lot more easier. Then real-time data exchange, very much possible. Facilitate high-speed surveillance and threat detection. Then advanced cybersecurity protocols, they are built into the 6G. So that is another use. So I take this from one of the published literature. I have quoted it below. So what we foresee is, it is not the centralized computing, the edge devices or the edge computing, that is really the go. You cannot centralized computing you do and then give the command to the edge or the peripheral devices. The peripheral devices should also be enabled to compute. This is where edge computing becomes important. And the communication, drone to network, drone to satellites, drone to other local networks, all these 4 things have to be enabled. So they have configured this for automobile vehicle, and I take the liberty from the authors to replace it by the ships. And the same technology holds good for these type of vehicles also. So today we talk about cloud. Whatever you talk about the clouds, and there is an initiative from Government of India to have their own dedicated cloud, not to depend on any other commercially available cloud. That is a very great initiative. But despite that, the high latency and limited bandwidth, the security risks and high cost for scalability becomes an issue. And this is where edge computing is very, very essential. So this would definitely reduce the latency. Edge computing process the data locally, so reducing latency and better and faster decision making. Then enhanced bandwidth. Data is processed closer, reducing the bandwidth requirements. Improved security, definitely because you are not so open. Then increased operational range, because edge computing enables expanded coverage and increased operational range. Added to this, we definitely need to look at the deep learning or the AI-based techniques. This would definitely help in object detection. A lot of work, we have also done some work on it, which I will show some work that we have done in this area. You can identify the objects of interest. You can do activity detection. For example, something like then threat assessment, environmental monitoring, data analysis. All this is a possibility. The challenges, of course, is the resource constraints, model size, power consumption, model complexity. How do you overcome this? And to overcome that, we have what is known as quantization. This also we are working now. So the right side graph shows you the size, shows you the number of parameters, and left the y-axis shows you the accuracy, and the x-axis shows you the operations or the complexity. As you can see, for example, if you look at NASTnet, which is very popular, the accuracy is very high, but flops required is also high, complexity is high, number of parameters is also considerable. Now, if you want to change that, because this is very uniquely done, and if you change the architecture, it won't help. Therefore, without changing the model architecture or complex hardware, how can I get advantage? That is through quantization. So quantization simply means floating point operations converted to integer and do that. So today we are talking about not finally do the quantization, you develop quantization aware training itself. That is very important. So this will reduce the model size, improve efficiency, enhance performance, and you can see the decrease in the energy, because this is very, very important. If you look at the energy consumption of the deep learning architecture in the world, it is 7th, it stands 7th apart from other 6 leading countries. So much power is being consumed, so we should be mindful. So model selection, quantization, deployment, monitoring and optimization is what we need to think about. Then applications in identifying threats, real-time monitoring, search and rescue, this is all where you can use. So we have done this work at our lab. This is one of the flagship projects we have done. This is called Eye in the Sky. Using the drones, can you identify when the video image comes, can you automatically identify activities like stealing, punching, kicking, etc.? Our student did a mock drill. We trained a data set and then used the deep learning network, and we are able to identify. We can identify the multiple violence activities in a given scene, and lat-long location can be highlighted so that law enforcers can take action regarding that. So this we published in a very leading international conference, and we were also interviewed by the British Broadcast Corporation, BBC, for our work. Then we have done how do you merge, because when you have cloudy environment, you only have a SAR image, optical image is not available. How do you merge that? Then flood detection. You can fly and detect how many people are caught up in any scene, including the animals, etc. Sorry, I'm rushing through. Then high-speed road tracking. Any path you can track automatically. This is vision-based navigation. Then when you have obstacles, you can fly the drone from the wood. So we have used the optical flow techniques, and other method is the linear regression-based technique based on AI stuff. Then situations like this is you can latch on to a moving vehicle. Of course, when you have sea, the situation is different. I understand the complexities, but for a moving UGV, we have proved just by one single camera how you can perch. And this is a project we did for Northeastern Space Application Center. The drone that can land on water and take off from water. I'll just show you the takeoff and then proceed next because I think I have exceeded my time. So these are, you can have small vehicles which can take off and land, and both aerodynamic and hydrodynamic design for the hull part of the vehicle and the floats are essential. So very smooth takeoff. I have the whole video of loitering and then smooth landing, but I will not take too much of time. And this is another important that we did. This is called the disguised face identification. Just to tell you that this was also featured in BBC. That clip is what you are seeing. Even when a person is covered with a mask or a mush and a beard and hat, we could still identify who that person is. You can see even a girl wearing a mustache and a beard, you were able to pick up. So this is the some of the things that we have accomplished using machine learning or deep learning techniques. We use a 14-point face architecture, but one of the problem is AI and ethics, because when we published this, we published under the guise that, okay, even if a criminal disguises, we are able to identify. So one of the professors from MIT said that this is a dangerous algorithm because you can also identify a celebrity who would cover himself and come. So AI and ethics is a big topic. So whenever you are using AI, recently the Hopfield, who got the Nobel Prize for his work in physics, which resulted in machine learning, he himself has said that AI technology should be seen very seriously. So these are all some indigenous things that our country is doing. I will rush through this, I am sorry, because of the time. So ultimately, the future is that AI, 6D technology, cloud and edge computing. Jai Bharat, Namaste.
Thank you, sir, for sharing your insights with us. Your wealth of knowledge and expertise on the subject is truly impressive and has left a lasting impact on all of us. Now, I would request Deputy Inspector General Jamal Taha, Tatrakshak Medal, Deputy Director General Aviation, to please come up on the stage to kindly present a token of appreciation to Dr. S.N. Omkar.
Thank you so very much. See, quickly, just to cut short, sea is a porous border. And our idea is what, that there are a lot many people who camouflage. They come up in different, the size is going to be the same. The idea is what, they can give you the dodge to the human eye, but in case if you utilize artificial intelligence in a mechanical fashion, that's a mechanical AI-powered eye, so that at least we can get these dodges in blind and check it out. So I would request, being in the Institute of Sciences Bangalore, just kindly work it out, and in case some technologies are... We will be very happy to work with you. And thank you so very much for your enlightening lecture.
Thank you, sir. With due respect, I request the speakers to adhere to the allotted time of 15 minutes. Moving on to our next presentation, which will be delivered by Commandant J.G. Narendran R., followed by Group Captain Abhay C. Deshpande, retired. Commandant Narendran R. joined service in 2010 and has since made significant contribution to both maritime aviation and the Indian Coast Guard's flying operations. The officer is a qualified flying instructor with over 4,500 hours of maritime flying experience. Notably, he is the first Cat A qualified instructor of the Indian Coast Guard. A standout achievement in his career was being the first production test pilot for the Indian Coast Guard's Dornier. Commandant Narendran's extensive experience, technical proficiency, and leadership in maritime aviation makes him a key figure in the Indian Coast Guard.
Group Captain Abhay C. Deshpande, retired, is a senior flight test engineer from HALTAD Kanpur. He graduated in electrical engineering and post-graduated in microelectronics from IIT Mumbai. He is an alumnus of Air Force Test Pilot School, Bengaluru. He has a total of 15 years of experience in flight testing, performance, avionics flight testing, and has also worked as Chief Engineering Officer at a transport base of Eastern Air Command.
The Dornier, a long-standing workhorse of the Indian Coast Guard, has played a crucial role in surveillance, reconnaissance, and maritime security. With advancement in avionics, sensors, and communication systems, these aircrafts are being upgraded to enhance operational capabilities, ensuring stronger coastal security and maritime domain awareness.
On this note, I would like to invite Commander Narendra Nar, followed by Group Captain Abhay Deshpande retired, who will present their combined expertise in transforming vintage Indian Coast Guard Dornier workhorse to technologically advanced Indian Coast Guard maritime asset.
Thank you. Thank you. Request for Mr. Kanyu, sir. Request for Mr. Kanyu. Additional Director General A.K. Arbola, President Tatrakshak Medal, Coast Guard Commander, Western Seaboard, Inspector General T. Shashikumar, Trust Chakra Medal, Commander Coast Guard Region, Northwest, Flag Officers, Senior Officers, Officers, distinguished panelists and speakers, ladies and gentlemen, a very good afternoon to one and all. It is an honor to present on the topic of transforming the vintage Dornier into a technologically advanced maritime asset. Our scope of the presentation is as flashed. The presentation will be covered in two parts, the initial part being the user perspective, followed by the OEM perspective on the modifications that has happened in the Dornier. It is not the strongest of the species that survived, nor the most intelligent, but the one most responsive to change. This powerful quote highlights the importance of adaptability. The changing and growing maritime threat by the Indian Ocean poses significant challenges to regional security and global trade. With vital shipping routes passing through these waters, the region is increasingly vulnerable to piracy, territorial disputes, and the rising presence of military powers. This has led to disruption in trade, undermining economic stability. It is essential for nations to enhance maritime cooperation, improve surveillance, and build stronger capabilities to safeguard free and secure navigation, ensuring peace and prosperity in the region. To enhance the technological part of capabilities, Indian Coast Guard felt the need for upgrades to encounter the growing threats. The Indian Coast Guard plays a pivotal role in safeguarding India's vast maritime borders, and its aviation assets are crucial in this mission. The Coast Guard's fleets include fixed-wing aircraft consisting of 39 Dornier 228, 20 advanced light helicopters, and 19 Chetak helicopters, providing unmatched surveillance, search and rescue, and reconnaissance capabilities. While the short-term need for a maritime reconnaissance aircraft was met by the early Fokker F-27 Friendship, the long-term successor was identified as the versatile Dornier 228 aircraft. The Dornier 228 is a twin turboprop stall utility aircraft designed and first manufactured by Dornier, Germany in the year 1981. 3 Dornier aircraft were obtained directly from Germany, while the first 2 arrived at Mumbai on 19 July 1986. In 2018, 1700 series Dornier were earmarked to undergo a midlife upgrade at HAL Kanpur, of which, as on today, 14 aircraft are handed over to Indian Coast Guard post-completion. The modifications included various new systems and replacements of certain old systems with state-of-the-art tech. The modifications undertaken are as flashed on the screen. For the ease of the audience, the modifications are grouped under 3 major heads. Initially, the airframe, followed by avionics, and followed by aero engine. Airframe. The major modification in the airframe, immediately visible from the exterior of the aircraft, is the change of the 4-blade metal propellers into the 5-blade composite propellers. The propeller is manufactured by MT Propellers Germany. The advantages of the modification include cruise performance enhanced by 2 to 3 knots, reduced weight of 80 pounds, unlimited blade life, FOD repairable blades with composite layup. Significant noise reductions, quicker engine start, reduced turbine temperatures during engine start are also advantages. Another modification in the airframe is the cabin layout. The mission management system integration of onboard sensors have provided for a much better cabin space, leading to ease of access and increased safety during emergency evacuations. The next upgrade we'll be discussing is in the area of avionics. The aircraft has undergone a significant revamp with vintage systems replaced by state-of-the-art glass cockpit environment. On the screen, you can see the main instrument panel avionics cluster of the old Dornier 228 aircraft, which has now been transformed into a modernized version to look like this. Let's walk through these panels to explore the detailed modification the system has undergone in the user segment. IDU. IDU stands for Integrated Display Unit. The traditional instrument cluster has been replaced with 4 integrated display units, consolidating all aerodynamic and engine instrument data into the IDU system. Each IDU is equipped with an address model, ensuring display of relevant data according to cockpit ergonomics. These IDUs are virtually interchangeable, enhancing system redundancy in case of failure. Even if 3 IDUs fail, the remaining unit ensures that all critical parameters can be monitored and managed efficiently. The IDU features several advanced technologies to enhance flight safety and navigation. These include 3D synthetic vision systems, highway in the sky, HITS, georeference hover vector, terrain alerting and warning systems, graphical flight management systems, digital flight recorder, and an integrated radio management system. The instruments have been modified as well. The airspeed indicator, which traditionally appeared like this, now has been upgraded to look like this. With added features such as the speed bugs and indicators for critical parameters and essential speed thresholds, along with trend displays. These enhancements provide pilots with clearer, more precise information, improving situational awareness and decision-making during flight. The traditional altimeter has been replaced with digital readouts, which are now fed by the ADATA computers, providing precise digital values along with reference bugs to assist in monitoring various altimeter settings. Additionally, the classical vertical speed indicator has been replaced with a warm indicator. The traditional artificial horizon has been upgraded to a TOS-enhanced synthetic vision system. The advanced system provides critical parameters such as attitude data, obstruction clearance warnings, and is also integrated with traffic data. The system offers selectable data, enhancing the pilot's situational awareness and making flight operations smoother and more intuitive. The IDU in itself is a topic that could take hours to cover in detail. However, for now, let's move on to the next instrument modification. RBP, or Remote Bug Panel, plays a pivotal role in the cockpit by providing access to all features of the integrated display unit. It is one of the most important tools, offering various selections of the glass cockpit while maintaining a heads-up configuration. This is particularly crucial when flying in maritime environments where maintaining a heads-up posture is essential due to the proximity of water. The RBP significantly enhances safety during critical Coast Guard operations such as search and rescue, positive identification of threats, armaments, close interrogation, and other essential tasks by facilitating easy access to vital information. The Electronic Standby Instrumentation System, ESIS, is a critical safety feature operating independently with its own ADATA computer and AHRU. This system delivers reliable data for attitude, heading, altitude, and airspeed, supported by a dedicated battery providing up to 4 hours of backup power. In the event of a total electrical failure, ESIS ensures that the aircraft safely returns to base. The aircraft is also equipped with the latest VHF-UHF AR1500 by Collins Aerospace. Key features of the system are displayed on the screen. The system proved its reliability during operations at the Maiden Republic Day flypast by the Indian Coast Guard, where seamless radio communications were maintained over both UHF and VHF frequencies with various agencies. The system also provides for communication on maritime bands, and it's reliable during sea-air coordinated exercises. The conventional autopilot has been upgraded to digital autopilot KFC 325 by Bendix King, a Honeywell company. This upgrade introduces additional features such as airspeed hold, soft ride, and half-bank modes. These enhancements help reduce cockpit workload by providing extended automation at various stages of flight, which improves overall operational efficiency as well. Moving on to the next area of modification, the aircraft engines remain the same as those in the previous conventional model, but the way the engine data is monitored and interpreted has been significantly upgraded. The aircraft now features the ECAS, engine indication and crew alerting system, which sends data to the IDU for display. This data is provided by 2 data acquisition units, which are positioned within the IDU itself. The DAUs receive digital data converted from the analog sensors installed on the engine. The system offers digital readouts and time-critical values, ensuring any deviation in parameters, both in terms of value and timing, triggers a warning to the pilot. The ECAS system also displays values for critical systems such as electric, fuel, aircraft control, and hydraulics. In addition, the crew alerting system offers a chronological sequence of warnings and cautions accompanied by audio callouts. The feature ensures that pilots receive both audio and visual indications, helping them assess the severity of the situation and effectively manage multiple emergencies. Sensors, the reconnaissance radar, and various other sensors on board the Indian Coast Guard Dornier are crucial for the aircraft's mission success. The radar enables real-time detection of surface targets, helping the crew monitor and identify potential threats or vessels in distress, even in challenging weather conditions. All sensors on board the Dornier are seamlessly integrated through the mission management system, an indigenous development by MCSRDC Bangalore. The integrated system provides state-of-the-art capabilities in maritime surveillance, enhancing tactical situational awareness, intelligence, and reconnaissance functions. The MMS connects all onboard mission sensors, systems, and the glass cockpit into one cohesive platform. We are going to discuss MMS in detail with the OEM representative in the later part of the presentation. The system architecture of the MMS offers a user-friendly interface that seamlessly connects the various onboard sensors to the displays tailored to meet mission-specific requirements. It provides the capability to display in various formats, including radar, topographical maps, ENC charts, vector maps, aeronautical charts, and other specialized modes. Integrated with MMS is a multi-mode X-ray band coherent radar capable of performing air-to-sea, air-to-air, and air-to-ground operations. It excels in detecting small targets at long ranges and under high sea states, making it ideal for both maritime and aerial surveillance. The radar offers multiple modes, enabling detailed target identification. The MMS ensures seamless interface and access to necessary parameters for effective mission execution. The inertial navigation system is also integrated to the MMS, providing a feed of critical navigation parameters by operating independently within the MMS framework. The INS contributes to systems reliability and precision during complex operations. The aircraft is equipped with a compact, multi-purpose, advanced stabilized system, which includes a forward-looking infrared camera, a color TV CCD camera, and an eye-safe laser rangefinder. These advanced systems provide high-resolution imaging and accurate targeting, enhancing the aircraft's capability in surveillance and search and rescue missions. The stabilization ensures clear and precise data capture, even in challenging conditions, making it an invaluable tool for the Indian Coast Guard in various operational scenarios. The aircraft is equipped with Class A transponder automatic identification system, enabling automatic tracking and identification of vessels. The system provides critical AIS data such as the vessel's call sign, ship's name, position, source, destination, and estimated time of arrival, all integrated into the MMS interface, where it can be displayed on a chosen background. The direction finder RT600 series is equipped with a multi-band airborne SAR-8, capable of operating across VHF maritime band, UHF aviation band, and the COSPA SARSAT frequencies. No additional equipment is required for its operation. The previous analog data is now available in digital form integrated with the MMS. The aircraft is capable of transmitting all the MMS data through the indigenous data link system, allows the transmission and reception of video from sensor data, target information, still images, text messages and reports. It supports point-to-point line-of-sight communication with capability to operate over point-to-point and point-to-multipoint communication modes. The system ensures reliable communication over a maximum range of more than 200 kilometers, providing seamless communication for effective mission coordination and data sharing. Out of these 17 aircrafts, 3 aircrafts are pollution surveillance variants. The previous cylindrical external antenna is now replaced with the flushed semi-cylindrical antenna and promises an improvement in performance values. The pollution surveillance system on board is developed by ST Airborne Systems and is integrated with the mission management system. It utilizes advanced sensors and imaging technology to identify oil spills, hazardous substances, and other environmental threats in real time, aiding in efficient pollution management and protection of coastal ecosystem. With this, I invite Group Captain Retired Abhay Deshpande, Senior FT, HALTAD Kanpur, for give us the OEM perspective regarding the modifications.
Having heard the operator's perspective, I will cover the functionalities and the features of the indigenously developed integrated mission management system, the high point of the Coast Guard midlife upgrade. Now, before designing any system, the first question that comes to the mind of the designer is, why I need to design this system? And the answer to that lies in the next slide. 17 Dornier 228 of Indian Coast Guard were integrated with ELTA 3.0 system. It was a Windows 8 based mission control, mission management system using which operator could control radar or EOIR pod. The operator was required to switch between the sensors to obtain the mission information from either of the sensor. Interfacing with automatic identification system required a separate control unit. Absence of interface with all onboard sensors, lack of integrated tactical situation display, and absence of data link impeded operators' capability and increased crew workload while undertaking maritime reconnaissance operations. To address this, HALTAD along with MCSRDC developed an integrated mission management system. The system is designed to interface and control all onboard sensors, those are available on Dornier 228 Coast Guard, and provide a seamless tactical display to operator. The system also interfaces with data link, thereby providing the operator a capability to transmit data or video to other aircraft, ground station, or to a ship. The system has a capability to do health monitoring of all onboard sensors and also possesses capability to record video, audio, and data for mission debrief. The system can be integrated in single or twin operator configuration with complete flexibility to control and operate all onboard sensors from either of the station. Twin operator configuration has been used on those Coast Guard MLU aircrafts which have been integrated with pollution surveillance system. Use of latest electronics has helped the designers in optimizing the size of line replaceable units, thereby aiding downsizing of the mission racks and consoles. The operator console of MMS is a 2-rail mounted as against the previous 3-rail mount design. This has enhanced the space availability in the cabin and eased cockpit accessibility from the cabin. The improved cabin layout has also facilitated fitment of few additional jump seats in case the same MLU aircraft has been deployed for any other role. The photograph depicts fitment of 4 jump seats while the aircraft still equipped with integrated mission management system. Coming to the main subsystems, the mission management system has 4 LRUs: interface computer, display computer, a 23-inch operator console display, and an integrated keyboard and trackball. In twin operator configuration, the system has 2 display computers and 2 23-inch operator consoles. However, there is only one interface computer in single as well as twin operator configuration. Console has a ruggedized 23-inch active matrix color display with sufficient viewing angle to provide complete visibility to operator. The display monitor has a DVI interface. The MMS system has one interface computer which interacts with all onboard sensors and also with the display computers. The interface computer is equipped with latest generation NXP series processor with a very high processing capability and has 6 different modules which are built using off-the-shelf items. As the name suggests, interface computer performs the functions to interface or to provide the interface for the integrated mission management system with all onboard sensors, the glass cockpit and the data link. The unit also receives navigation data from the glass cockpit and forwards mission plans to flight management system of the aircraft. Coming to the next display computer, the next LRU is based on Intel Xeon 9th generation processor and has a dedicated general purpose graphics processing unit with a 32 GB RAM. The display computer generates 3 independent DVI outputs which are fed to operator console and multifunction display in the cockpit. The module also performs functions such as transferring keyed operator inputs to interface computer and recording of onboard video, audio and data. For recording purpose, the module has a 2 terabyte removable memory module which is adequate enough to record the mission data. Sensor fusion and target correlation tasks, when demanded by the operator, is also performed by the display computer. Sensor fusion and target correlation is an important feature which was not available in the previous ELTA system that was available with Coast Guard. MMS receives targets through data link, AIS and radar, presenting the same track picked up by these 3 sensors as independent targets increases operator workload to isolate the targets. Inbuilt feature of sensor fusion and target correlation generates a unique track for all correlated targets. Operator can demand the target coordination or target correlation by drawing a rectangle encircling all targets which are to be correlated. To achieve the target correlation, all selected targets received from the 3 different sensors are timestamped, and targets with same timestamp are filtered using a correlation window that uses target position, speed and course. While filtering the targets, weightage is assigned as per the sensor accuracy, and permissible positional difference has also been accounted while correlating the targets. Another important feature which was lacked or which was not available in the previous management system was the creation of flight plan by the operator. In this system, operator has a flexibility to create the flight plan and transfer the same to cockpit in the flight management system. With the availability of nav FMS mode in the autopilot, pilot can activate the flight plan and fly the mission on autopilot. This is how the interface between the mission management system and the nav FMS works. The symbology provided on the tactical situation display page is intuitive and easy to operate. All onboard sensors are provided with soft key selection options. Depending upon the selection, operator can open multiple control and display windows to have information obtained from various sensors. These windows are openable in picture-in-picture format. It is worth mentioning here that the previous system, the operator was required to switch between the radar page and the UR page, which was hampering its situational awareness. The MMS enables streaming of EOR video, radar display, PSS video, or IR UV scanner video into the cockpit. In the Coast Guard Dorniers, Copilot MFD has been earmarked for display. However, depending upon the user requirements, the system can be configured to display the same on any other or all of the display units. An encoder knob provided in the center pedestal gives the crew flexibility to select the video. Availability of these videos into cockpit has improved the decision making significantly. Another important aspect of the newly developed integrated mission management system is an automated report generation, and wherein the operator has an option to customize the parameters or the content of the report. Having seen the integrated mission management system and enlightened with the previous speaker's talk on the artificial intelligence, I take this that yes, artificial intelligence and the use of that into this system will be the way forward and can be considered as a future development. MMS being an indigenous design, there is a complete visibility and control over the hardware and the software. In-flight recording of several sensor data can be used to train the system for predictive analytics, anomaly detection, and automation. This will be a potential future development. Integrated mission management system is a state-of-the-art system that has transformed maritime reconnaissance operations of Indian Coast Guard. With this, I call upon Commander Narendran to conclude.
In conclusion, the comprehensive upgrade of our aging fleet is a momentous step forward for the Indian Coast Guard and the nation. Not only will we be upgrading the entire fleet of Dornier 228 aircraft in the future, but we are also advancing our commitment to indigenize the development of our own airborne mission management systems and sensors, strengthening our self-reliance. This upgrade will significantly enhance our maritime capabilities, incorporating state-of-the-art systems that improves mission safety while refining the efficiency and effectiveness of our operations. This upgrade created a pivotal moment in modernizing our fleet, fortifying our operational readiness, and ensuring safety and security of Indian Ocean region for the future. Thank you. Vayam Rakshama. Jai Hind.
Thank you, sir. I'm sure that the insights and perspective on the transformation of Dorniers have added immense value to this forum. And now I would request Deputy Inspector General Jamal Tahat, the Rakshak Medal, Deputy Director General Aviation, to please come up on the stage to kindly present a token of gratitude to Commandant J.G. Narendran R.
Just to put a word across, I think after seeing this presentation, one can imagine that technology cannot make, does not allow a machine to age. And if I can put across, HAL TADA Kanpur is like a make-up man team, which makes the old horse to be the one which is agile and, of course, effective in carrying out the operations. For our foreign, guest, this is the capability which the country has developed on its own. And I'm sure you can see that we are flying this machine since 1986, and still it is one of the state-of-the-art solutions which are available here. We are the pioneers as far as the operation of the Dorniers is concerned, not in India, but across the world. We have logged somewhere around 375,000 airframe RAS, and approximately 175,000 landings we have undertaken. And it is proud to say that Coast Guard fleet is purely indigenized. Thank you, gentlemen, for your presentation. Hello. Yes, sir. Yes, sir.
Group Captain Abhay C. Deshpande, retired.
Nice to see you in the observer room today.
Mr. Sudhir Kumar, Chief Manager Design, HAL TAD Kanpur. Excuse me, sir. So request Deputy Inspector General Jamal Taha, the Rakshak Medal, Deputy Director General Aviation, to please present the memento to Mr. Sudhir Kumar, Chief Manager Design, HAL TID Kanpur. Thank you, sir. The last speaker is Dr. R. Rajesh, Scientist G, Deputy Group Director, Center for Airborne System, DRDO Bengaluru, who did his BTech in ECE from NIT Calicut and PhD from Indian Institute of Science, Bengaluru. Since 2002, he is working as a scientist at CAPS, where he is presently heading Division for System Engineering, Sensor Development, Multi-Sensor Data Fusion, and Artificial Intelligence. His areas of interest also include radar systems, information theory, and wireless communication. He has won various awards and has been commended for contribution towards airborne early warning and control systems.
We'd like to invite Dr. R. Rajesh to kindly share with us his analysis on indigenized technological tools for enhancing maritime reconnaissance.
Good afternoon to all. So my talk will be just a follow-up of what my previous speakers have spoken about. So I would like to dwell upon some newer technologies that are considered to be infused in such aircrafts. So if you see the context, to set the context, where we stand or what is the operational scenario, so we are in the Indian Ocean operating region, and we have a vast coastline over 7,500 kilometers, 2,000 plus islands, 13 major ports, and a lot of minor ports. 95% of our operations or trade happens through the sea routes. 4.6 million square kilometers of ISRR, which is Indian Search and Rescue Region, and 2.37 million square kilometers of exclusive economic zone. So what happens in a vast maritime environment like this is accidents, piracy, oil pollution, maritime terrorism, and a lot more. So this is the context, and this necessitates credible surveillance, search and rescue, and interdiction capabilities in our waters, and Indian Coast Guard is the nodal law enforcement agency there. So with this context, I'll tell you about the technologies that we can ramp up towards providing a better operational scenario for the Indian Coast Guard. So the first is we need platforms, and in platforms, two themes are important. One is layered surveillance, which means that we need to understand the global view and we should be able to focus to the last mile. So this is called layered surveillance, and second is cooperation. All our assets should be networked. So these two are the themes in platforms, ranging from satellites to drones to manned aircrafts. The next important theme is advanced sensors and communication equipment. The third one, as touched upon, is it is not just important to have just sensors in bits and pieces. We need to cohesively integrate these sensors into a powerful concept, into a mission concept. So mission management systems becomes important. The next one is the multi-sensor data fusion, which acts like a brain of the system, which combines all the sensors, not just combination, it provides multiple other vital information that the human eye may miss. The next one is AI and ML. Of course, we need to introduce this paradigm into all our sensors, into our concept of operation itself. And the last one, it's not just important to have platforms, we need to team the platforms up. So these are the themes which I would be dwelling upon. So so I'll be talking about multi-mission maritime aircraft, which is a manned surveillance platform, which CAPS, DRDO, the organization I represent, is working on. So we are the nodal agency for development of AAA for Indian Coast Guard. So this is a pictorial view of the AAA, which is on C295 aircraft. And the platform will be manufactured in India by Tata Advanced Systems, and the OEM of the aircraft is Airbus. And this is a fully role convertible aircraft supporting multiple roles. And this is the only one aircraft that we will have right now in such a variety of roles. So if you say this, see the sensor fits of AAA, the sensor fits are divided into surveillance suite. So surveillance suite, we have multiple radars, advanced radars, and a lot of cooperative surveillance systems. The pollution surveillance suite, a suite of 5 sensors. The communication suite, a plethora of communication starting from HF to K-band SATCOM, and powered by a mission management system and 3 multifunctional tactical consoles along with other sensors. So if you see this configuration on C295 or any other MPAs across the world, Indian AAA will have more than 30% of extra sensors. So this is the takeaway. Now I'll develop on some technologies that we propose or we are currently under feasibility study for incorporating onto the Indian AAA. So the first one is what is known as a software-defined radar. So we have moved from the conventional AESA-based radars. So earlier we had mechanically rotating radars. The second generation was AESA-based radars. Now we are standing at software-defined radars. So basically, if you see the software-defined radar, it can do the radar functions, it can do communication, it can even do passive sensing. So in the same aperture, we can get radar, communication, and ESM together. So which will be a great asset, not only for the AAA, maybe for the upcoming drones. So the building block of such a radar is what is known as a tile. So to give an example of tile, if you see that LCA picture, the current video wall is generated out of tiles of LEDs. So the radar will be built up of a tile like that, so which makes it inherently scalable. So somebody defines the integration volume, the tiles are arranged so that each time there is not a new radar development. Right now how we develop radar is, each time there is a new development based on the platform, because platforms are ever changing. So this is an X-band 16 transmit and 16 receive tile, which means that at a point the radar can transmit 16 waveforms. And why this is important is the next generation warfare or the current generation warfare with the autonomous vehicles coming in the sea surface. For example, somebody is doing a drug transport or a weapon transport through an autonomous vehicle. Their maneuvers are different, their RCS is different. So we cannot go with a ship detection radar and detect that. So you need to detect right from a 200 nautical mile ship to this, which needs much more powerful capabilities in the radar, and the capability is software-defined radar on chip. So if you see, this is the RFSoC module, which generates the waveforms, multiple waveforms and multiple receives. So this configuration, what is shown in the picture, supports 32 transmit and 32 receive channels. So, and it is a radar on IP, exactly like how computers are networked, the radars can be networked, multiple apertures, and it's a large MIMO system. So it's a multiple input, multiple output radars. So you probe the target using all sorts of equipment or radars or all sorts of waveform that require to achieve this capability. Another development that we are doing is for the oil spill. As you know, the SLAR is the primary detection sensor for such an application. So this is a new antenna that we have developed, the SLAR antenna. It's based on what is known as a cladded radome technology. If you see the conventional SLAR integrations with respect to the newly developed antenna, it is having just 5.5 kg. It's a dramatic reduction of 70% from most of the existing installations, and a size reduction of over 30%. And including some of the OEMs from Germany has expressed interest in importing this from us for their fleet. Now, like touched upon, mission management system is a very important component for cohesive integration. So our mission management system concept is slightly different. So we are going by what is known as a service-oriented architecture, which means that the sensors can be integrated into the mission as plug-in, which means that all upgrades of the sensors, various class of sensors, the integration effort should be reduced. So this is the aim with plug-in based integration. The second thing is it follows a cloud-based architecture, which means that the mission management system is not just one. It's a distributed cloud of small computers, which means that the system will be inherently resilient and robust to maybe reboots or anything of one computer, which means that you will not have a mission loss because of this mission management system, which is the central computer not being available. So this has been proven in some of the integrations that we have. Next is the multifunctional tactical consoles. Here we are deviating from the conventional concept. We will be providing a touch screen. With the increased number of sensors that are available, the operator needs to work with both hands. So one hand will be on the mouse, one hand will be touching. So it's a dual screen, and it's a triple touch, and again a layered architecture, and all these software are made as platform independent. So any OS, any kind of physical interface, these softwares can go with very, very minor modification. That is why it's called platform independent. So this is one of the integration that we are showing with 3 screens, and the back end of it is Indigenization. Even the GIS, it's indigenized. So we are not depending on a foreign GIS. So GIS is developed by DRDO, which is even the Naval Maritime Domain Network runs on Indigenization. So it can be integrated there also. So next important thing is multi-sensor data fusion. So we have plethora of sensors. So all these sensors not only just needs to be integrated at the display level. That is easy. Making it to the single display and showing it through the display. But what has to happen is, like our brain processes the information, we need to integrate them at the raw data level. So this is what multi-sensor data fusion does. And there are 2 aspects to it. One is kinematic fusion, wherein which we pinpoint and give precise location information or the motion characteristics of the target. Second thing is attribute fusion, wherein which we identify and classify the targets. It also does identification and threat analysis. The third one is to represent all these things at as close to the true world in a perceivable manner to the operator. So this is called a common operating picture, which will be flashed on the dual screen. It doesn't end here. After this, we run the AI algorithms for actionable intelligence, anomaly detection, intent prediction, and actions. So in the AMSDF, even there are AI modules. Since with the new vehicles, the motion characteristics are not fully known, so you cannot write rule-based algorithms. So these algorithms are developed based on, the machine is taught what will be the typical motion maneuvers and all those things, and the tracking and fusion can be done using an AI-based algorithm. I'll also show an AI-based video fusion. So this is HAL hangar from our office. So if you see the day image, you can see an aircraft standing there. This is the thermal image. You can see the structures inside the hangar. So what we will be projecting to the operator is a third video, which is a composite of both done using AI-based fusion. So this is a video. So it's a video fusion which happens at real time. So this video will be projected to the operator so that the operator needn't switch between 2 screens for his situational awareness. We also have a full-fledged test bed at CAPS for multi-sensor data fusion, basically for algorithm benchmarking, for development, integrated testing, and hardware-in-loop testing. So this is the whole setup there, which can benchmark multi-sensor data fusion algorithms. Next theme is actionable intelligence, which is more of AI. So right from the sensor to the image processing, to the multi-sensor data fusion, to the common operating picture, we need to have detection of the object, identification or classification of the object into different classes, then coming to what exactly is that class, is it a Boeing class or whatever it is, and then doing actions on it. So this helps the operator in 2 folds. One is it's a decision support system. And second is sometimes if the decision is not catastrophic or it can be parted to the machine, it can be given as an autonomous decision making. So this is an airborne camera that we have. So we have integrated it to an AI hardware, making it an AI-enabled camera. So you can see the object detection. So these are live images from that camera. Again, EO plus IR video fusion I have already touched upon. Another important thing is in a single wild FOV frame, we can have multi-target tracking, which the conventional EOIR will not be able to do because he has to slew to that particular position. Next is change detection. Even for battlefield damage assessment or oil spill monitoring, change detection is an important algorithm. Another important algorithm is magnetic segmentation. This is typically a SLAR image. So how to cut the SLAR image so fine for volume estimation of the oil. This is another use case. Another AI-based application that we have is natural language processing. So any communication that you decode or intercept or even live speech, we can decode this 80 plus national and international languages. Real time we can transcribe it and give the output in both English and Hindi. And this can act as in the future for voice commands, and it's a language agnostic thing, like it can take 80 plus languages. The last theme is MUMT, which is man and man teaming. This is basically about teaming the manned asset with drones. So what does it improve is it provides effective work division between the manned aircraft and the drones, and it can act as an added hand to the manned aircraft. So the basic thing was started for the stealth detection. However, we can go into something like we have this AAA rear ramp door. Drones can be launched. Various kind of drones, they can be sent forward. The data can be collected to the mother node and then disseminated. Another technology that we are working on is called RIS, which is Reconfigurable Intelligent Surfaces. This is to alter the channel. Right now, transmitter you can modify, receiver you can modify. What about the channel? So this is a technology which allows us to modify the channel using what is known as metamaterials. So these are some of the use cases wherein which if you have a blockage due to a mountain, how to align the RF towards your receiver, how to use it in MUMT, and maybe how to improve the coverage in certain installations. So with that, I conclude. The conclusion is the maritime scenario is an ever-challenging and changing field. So we need what is known as scalable technologies, and we need ubiquitous and robust networking. We need the capability to infuse newer sensor technology. Irrespective of the integration, this thing we need to infuse it. And we need advanced mission management tools, cohesive multi-sensor, multi-platform integration, and AI-enabled paradigms. And MUMT, like I said, is also a force multiplier. With that, Jai Hind, and thank you.
Thank you, sir. Your commitment to your subject was evident, and it was truly an honor to hear from someone who is dedicated to make a positive impact in the world.
Now I would request Deputy Inspector General Jamal Taha to please come up on the stage to kindly present a token of appreciation to Dr. R. Rajesh.
Dr. Ragesh, it's nice to know that you are actually transmitting now through software-driven radar. I think this may be one of the solutions for drone things also. The beauty of scientists is that their time is always short. They've got a huge amount of the knowledge. And in the lighter vein, I think the talk is extending to a limit so that they don't allow the people to ask questions also. Anyway, it was an enlightening talk. Thank you so very much.
Thank you, sir. Sir, I would request sir to remain please on stage, sir. Moving forward, I request Additional Director General Anil Kumar Harbola, President Tat Rakshak Medal, Tat Rakshak Medal Coast Guard Commander Western Seaboard, to please come up on the stage to receive a token of remembrance. Sir, please, sir.
Thank you, sir. Further, I request Inspector General T. Sashi Kumar, Tatrakshak Medal, Commander Coast Guard Region Northwest, to please come up on the stage to receive a token of remembrance. Thank you, sir. Thank you, sir. With this, we come to the end of the presentation session. Ladies and gentlemen, today, through a short film, we invite you to witness the essence of the Indian Coast Guard, its mission, its challenges, and its unwavering spirit. Let the screen unfold the story of those who keep our seas safe so that the nation may prosper. We present to you the Indian Coast Guard.
In a nation bound by the ocean where the waves tell tales of bravery and resilience, there stands a force, steadfast, silent, yet ever ready. This is the story of the Indian Coast Guard. For 48 years, we have defended our waters with unwavering courage and a relentless commitment to protect. Since February 1st, 1977, we have grown, evolved, and adapted. Our mission was born from a need to safeguard India's vast coastline, maritime interests, and its people. Being the guardian of India's coastline isn't easy, especially when we have to keep more than 11,000 kilometers safe and secure. But nothing escapes our watchful eye. We are vigilant at all times, at all places. Our duties are as vast as the ocean itself. Search and rescue, maritime law enforcement, environment protection, and disaster relief. We are the guardians of the blue, dedicated to ensuring maritime security and protecting our waters from threats like terrorism and extremism. Our mission extends to rescuing civilians during natural disasters, preserving the delicate balance of marine ecosystems, and countering illegal activities such as smuggling and unlawful fishing. As we commemorate 49 years of unwavering vigilance, we salute our guardians of the Indian seas. Our journey is one of courage, humanity, and inspiration. The Indian Coast Guard, securing horizons, safeguarding tomorrow. Join us in our journey where courage and dedication shape every horizon we safeguard. The Indian Coast Guard, your steadfast maritime protector.
Ladies and gentlemen, we just witnessed the challenges faced by our maritime defenders, which are immense, ranging from safeguarding our vast coastline to conducting daring rescue operations and ensuring maritime security to live up to our motto, Vayam Rakshama. Their dedication, resilience, and strategic approach to handling complex situations plays a crucial role in maintaining national security and protecting lives at sea.
With this in mind, we now proceed to an insightful panel discussion where esteemed experts will share their perspectives. The panel will be discussing on the subject, Challenges in Indigenization and Resolution. We have a distinguished group of 4 panelists, and I am confident that the discussion will be both enlightening and thought-provoking.
I would request moderator for today's panel discussion, Deputy Inspector General Jamal Taha, Tatrakshak Medal, and the panelists, Dr. K. Rajalakshmi Menon, Director General Aeronautical System, DRDO Bengaluru, Professor Suresh Sundaram, Department of Aerospace Engineering, Indian Institute of Science, Bengaluru, Shri Kanwal Krishan Bhatt, Chief of Production, Head of Accessories Division, HAL Lucknow, Dr. Naresh Palta, Senior Advisor, Maini Group, Maini Aerospace, Bengaluru, to please come up on the stage and take their respective seat. Deputy Inspector General Jamal Taha is at the helm of affairs in the Indian Coast Guard Aviation. As Deputy Director General Aviation, he is a distinguished leader in Indian Coast Guard's aviation fraternity, and as Principal Director Air Material at the Coast Guard headquarters, plays a pivotal role in aviation logistics, maintenance, and management of Indian Coast Guard air assets for optimum effectivity. His academic credentials include a Master's in Aerospace Engineering from Indian Institute of Science, Bengaluru, a Master's in Industrial Engineering from Aligarh University, and various specializations in the field of aviation and marine engineering. He has been a panelist and moderator at various prestigious forums like Aerospace and Defense MRO, South Asia Summit, IIT Delhi's EMRO. Erudite in today's topic, his academic inclination, dovetailed with his vast experience, adds to the flavor of the panel discussion.
Our first panelist needs no introduction, and it gives me great pleasure to welcome Dr. K. Rajalakshmi Menon, Director General Aero DRDO, whose achievements and qualification can humble the greatest of minds. Dr. K. Rajalakshmi Menon began her career at DRDO in 1988 as a Scientist B at Center for Airborne Systems, then known as Airborne Surveillance, Warning and Control. Subsequently, she had served as a Director CAPS from 31st December 2021 till 18 November 2024, wherein she steered the airborne surveillance programs. Presently, she holds the coveted post of Director General Aero from 1st September 2024, wherein Madam is steering aero cluster activities of DRDO. Madam holds multitude of academic achievements, notably MSc in Computer Science from the University of Pune, Masters in Engineering, and a PhD in Aerospace Engineering from the Indian Institute of Science, Bengaluru. She is a Fellow of National Academy of Engineering and a Senior Member of Institute of Electrical and Electronics Engineer. It's a distinct honor to welcome you, ma'am.
Thank you, ma'am.
We also have amongst us Professor Suresh Sundaram, Professor in the Department of Aerospace Engineering, Indian Institute of Science, Bengaluru, since 2018, and Associated Faculty in Robert Bosch Center for Cyber Physical System. Dr. Suresh received his Bachelor of Engineering from the Bharatiya University and his Master of Engineering and PhD from the Indian Institute of Science. He leads the WIPRO, Indian Institute of Science Contribution Joint Research Initiative on Artificial-Driven Autonomous System and in an autonomous vehicle in AI and Robotic Technology Park. A very warm welcome to you, sir.
We are also joined by Shri Kaval Krishan Bhatt, Chief of Production, Head of Accessories Division at HAL Lucknow. He holds a BTech in Mechanical Engineering from NIT Warangal and an MBA in Operations Management. He joined HAL as a design trainee on 17 July 1995 and has since played a crucial role in shaping the Accessories Division strategic growth. Under his leadership, HAL Accessories Division received the Best Division for Indigenous Efforts, and he has been consistently recognized for achieving financial milestones. A very warm welcome to you, sir.
Continuing their contribution to the seminar, as panelists, we are fortunate to also have Dr. Naresh Palta, Senior Advisor, Aerospace and Aviation, Many Group. Dr. Naresh Palta, a PhD in Business Management, began his career as aeronautical engineer with a bachelor's degree from Punjab Engineering College, Chandigarh. He joined Hindustan Aeronautic Limited as a management trainee in 1969 and served there for 4 decades until his retirement in November 2008 as Corporate Executive Director. During his tenure, Dr. Palta transformed HAL's aftermarket support, quality assurance, and flight safety, significantly enhancing aircraft fleet utilization for defense customers. Currently, he holds the position of Senior Advisor, Aerospace and Aviation for the group. Extending a cordial welcome to you, sir.
With the audience now apprised of the sheer volume of knowledge and experience that we have here, I would request Deputy Inspector General Jamal Taha to kindly commence the panel discussion. Sir, please.
So, thank you, ladies and gentlemen, for your grand presence here. It is indeed an honor and privilege to steer the session 2 as a moderator. Prior diving into the discussions on challenges in indigenization and resolution, I've got a greater challenge upon my sleeves, that how to wrap up the entire conversation in 40 minutes with knowledge-packed panelists. But having said so, each of the panelists, what our MC has just spoken about, if you allow them, they can speak for hours altogether. But on the flip side of it, one of the beauty of an expert is that like a poet, they can condense the entire knowledge in few sentences. So we will be looking after this kind of a trait today because of the paucity of the time. Anyway, I'll just go in a non-conventional way this time, just because the paucity time. Generally, what happens, the Q&As after the discussion is over. But I would, just to create the inquisitiveness among the audience, I would request that on the topic which I just spoken about and repeat the challenges in indigenization and the resolution, if you got certain questions, you please raise your hand. I'll just take 2 or 3 questions, and subsequently we will try to take it up during the discussion with the people. I think there will be some, we are anticipating our Honorable Rajya Raksha Mantri, who's going to grace the occasion as the chief guest. So during our discussions, we'll have a pause and subsequently we'll take off. So if anybody has got any questions about today's discussion. Anyway, so let us embark and enjoy today's discussion. And ladies and gentlemen, indigenization has become a buzzword since 2018, when Honorable Prime Minister thought that let's cap the forex, foreign exchange, and try to build up our own knowledge, utilize our own resources in an effective fashion, and let's see what can be done. And since then, I think it has become a motto in whatever domain, in whatever areas the people are working on. We also know that the indigenization is a key to, I should say is the prime mover, is the key, is the engine for the carrying out the indigenization. And research and development is supposed to be the key for driving the indigenization. But like, you require budget, you require money to get this indigenization rolling. If you look at the country scene as of now, we spend just 0.66% of the GDP only in R&D. And if you see the national or the world average, it is of the order of 2.26. That's a world average. And if you look at the different countries, Israel stands right at top with an investment of 5.56% of the GDP. There is a saying, that if money makes money. If you invest money into the R&D, then definitely you will get a benefit. And a clear-cut examples, I've just spoken about the Israel. They got $195 billion, the economy, and out of that, if somebody is spending of the order of the 5.5%, 5.56% of the GDP, the results are known to us. If you look at our aircraft, what I've just spoken about, we have got a maritime patrol radar with us. We have got an EOIR available with us. These all are coming from Israel. But the good part is that after the voicing of this indigenization, things are changing fast. And our resources, whether it is money or whether it's humans, both are being basically channelized in the right frame of mind, and things are really changing. uh, a very important aspect which Economic Survey of 2020 and 21 has projected, that if really wanted to grow as in India, we need to have 2% of the GDP expenditure in our R&D. That's a prediction in 2020 to 21. And it is clearly visible also. Now, if you see the R&D aspect, so we got three main pillars as far as my perspective goes. One and the foremost is the scientist, second is the academia, and third is the industry. If you look at from a different perspective, that if these three are called as a fruit-bearing tree, and you really wanted to grow the tree, you need water. In the similar fashion, like a fruit-bearing tree, if you try to give them due amount of the money to R&D to grow, I don't find any reason that why we can't grow. Now, in a brief, so as usual, life is full of uncertainty. Things happen at a pace which you can't anticipate also. But anyway, I think RRM is right on its way. I'll just stop here and then again pick it up. Angelo, is he on it or you are on his way? Where is he? Come on, okay. Once he's there, he'll be. So anyway, I think I will stop at the moment gentleman is here. So what I was talking about is the economy survey said so that if you invest 2% of the GDP in R&D, then things are going to be changing. Now, the beauty of the country is what, that in less than 8 years, 2018 and we are in 2024. In less than 8 years, we have done wonders. Is he there? So I'm sorry that doesn't happen since RRM is coming. I'm sorry that I will request you panelists to occupy the seat, please. I'm sorry. I'll be holding your seat. I'll ensure nobody sits here. So, ladies and gentlemen, we are honored and privileged to welcome amidst us our esteemed chief guest, Shri Sanjay Seth, esteemed Raksha Rajya Mantri, who has graced the occasion. Thank you, sir. Sir is an alumnus of Commerce and Law with a postgraduate diploma in Business Management, specializing in Industrial Administration from the Delhi Institute of Management. Shri Seth brings a wealth of knowledge and experience to his role. Throughout his tenure, he has been instrumental in advancing India's defense capabilities, emphasizing modernization and self-reliance. Recently, I was witness to the oratory skills of Sir in a seminar on 9th of February in the Semilac, where Sir was addressing to the foreign tenders, foreign representatives. And as Sir name starts with SS, so suddenly my mind has gone a different role altogether. In our childhood days, the batter used to bat with a symbol which was written SSS. So the way the words were coming out from Sir's mouth, it was like, a skilled batsman is playing and playing shots in all around. So Sir has got an oratory skill also. His leadership reflects a profound commitment to strengthening our nation's security and supporting the welfare of our armed forces. Ladies and gentlemen, please join me in extending a warm welcome to the esteemed Honorary Rashtriya Raksha Mantri. Sir, your presence really honored us, and I would request now to Honorable Rashtriya Raksha Mantri to kindly address the gathering.
भारत माता की वंदे डॉक्टर के राजलक्ष्मी मेनन, प्रोफेसर सुरेश सुंदरम, सी कंवल कृष्ण भट्ट, डॉक्टर नरेश पाल्टा, eminent dignitaries, CGC Western Seaboard, Indian Coast Guard officials, esteemed speaker, academia, DPSU and industries, organizer, participants, press, media and personal guests. I extend a big welcome each of you. It is an immense privilege to stand before you at this prestigious seminar organized by Bharatiya Tat Rakshak on the transformation of maritime aviation by adopting technology trends and indigenization. This gathering is not merely an event but a defining moment in the evolution of maritime aviation, a domain that serves as a backbone of national security, maritime sovereignty and global commerce. Today we embark on a journey to explore the future, this critical industry embracing cutting-edge advancement and referring our commitment to self-reliance. Bharat, a formidable maritime nation, is endowed with a vast, strategically significant coastline stretching 11,000 kilometers and 1,389 islands, 13 major ports, and 239 minor ports. Our maritime responsibility extends over 4.68 million square kilometers of the Indian search and rescue region and 2.1 million square kilometers of the exclusive economic zone, safeguarding vital offshore installation in Iceland of immense strategic importance. This vast expanse in just a realm, geographical significance, but a bustling corridor where over 12,000 ships, numerous aircraft navigate through the Indian Ocean region and more than 2 million fishermen. ये गौरव की बात है कि ऐसे हजारों हजार जो फिशरमैन हैं जिनका परिवार उस समुद्र के पानी से चलता है और जो आप समुद्री सीमा है वह समुद्री सीमा कम खतरे से कम नहीं है। 140 करोड़ देशवासी आपके भरोसे देश के नागरिक अमन चैन, चाहे वो बाहरी खतरा हो, चाहे स्मगलिंग हो, चाहे ऐसे अपराध जो समुद्र के रास्ते से होते हैं, आप दिन रात मेहनत करके आप जैसे लोग जो मां भारती की सेवा, आप जैसे लोग समुद्री सीमा की रक्षा अपने परिवार से दूर रहकर, सबसे पहले मैं ऐसे सारे कोस्ट गार्ड के सभी ऑफिसर्स जवानों को मेरा बहुत बड़ा पूरे देश भर को सैल्यूट। मैरीटाइम सिक्योरिटी हमारी प्राथमिकता है और इसीलिए इस साल के रक्षा के बजट में आप देखो 9,000 से 676 करोड़ 9,676 करोड़ रुपीस, पिछले साल से 27% अधिक, और इसमें लगभग 5,000 करोड़ रुपया कैपिटल बजट के लिए, उसमें आप जिसमें एडवांस लाइट हेलीकॉप्टर, ड्रोन एयरक्राफ्ट, फास्ट पेट्रोल वेसल, ट्रेनिंग इंटरसेप्टर बोट, कैसे समुद्री सीमा सुरक्षित रहे। प्रधानमंत्री नरेंद्र मोदी जी का संकल्प, और उस संकल्प को आप पूरा कर रहे। पूर्व में घटना हुई आज से कई साल पहले, लेकिन आपकी तत्परता, मैं तो आपके माध्यम से देशवासियों को बोलता हूं कि आज कोस्ट गार्ड का एक एक जवान समुद्री सुरक्षा के लिए पूरी तरह तैनात है। अब दुनिया का कोई माई का लाल भारत की समुद्री सीमा से आके भारत में अपराध नहीं कर सकता। हमारा लक्ष्य 2030, जब 200 सतही प्लेटफॉर्म के साथ 100 विमानों का लक्ष्य प्राप्त करना है, जहां एक और विकसित भारत का संकल्प 2047, जब भारत अपनी आजादी के 100 साल मनाएगा, वहीं दूसरी ओर कोस्ट गार्ड का सपना, कोस्ट गार्ड का संकल्प 2030, 17 साल पहले, 2047 के 17 साल पहले, और वह कोस्ट गार्ड जिसका आदर्श वाक्य है कि वयम रक्षम, हम रक्षा करते हैं 140 करोड़ देशवासियों का, मां भारती की रक्षा। उस प्यारे न्यारे तिरंगे की रक्षा। और आपने अपने कर्तव्य, अपनी जिम्मेदारी, जिसमें अभी तक 11,000, मैं देशवासियों को बताना चाहता हूं कि कोस्ट गार्ड के जवानों ने देश में 11,730 लोगों की जान बचाई। एक एक जान की कीमत होती है। और इस वर्ष लगभग 169 लोगों की जान बचाई। मैं आपको सैल्यूट करना चाहता हूं, देशवासियों की ओर से आपको धन्यवाद और बधाई देना चाहता हूं। मित्रों, the rapid march of technology heralds a new dawn in the maritime aviation, one marked by groundbreaking advancement in artificial intelligence, automation, unmanned aerial vehicles and data analysis. और हम कह सकते हैं कि जो आपका हौसला है, उस हौसले में कोई कमी नहीं। और इसीलिए to realize this vision, we must invest heavily in research, development, innovation, fostering collaboration between DPSUs, private enterprises, defense experts and research institutions. Or only through synergy and strategic partnership can we ensure that our technological evolution aligns with the overreaching objective of our maritime forces. आज दुनिया भारत की ओर देख रही है। भारत की तेजी, भारत का रक्षा कवच, और उस रक्षा कवच में आज से कई साल पहले दुनिया हमको कहते थे, भैया ये तो अनपढ़ों का देश है, यहां तो रक्षा के क्षेत्र में बुलेट प्रूफ जैकेट नहीं होती थी, बूट्स नहीं होते थे। ज्यादा समय नहीं, कुछ 40-50 साल भी नहीं, कुछ ही साल पहले देखो भारत की ताकत। हमने वो समय भी देखा था कि जब पोलियो आया, हैजा आया, दुनिया ने आपको सुरक्षित कर लिया। उसके 12 साल बाद भारत को पोलियो का टीका दिया, दुनिया ने सुरक्षित किया अपने। और नए भारत की ताकत देखो, कोरोना आया, हमने तो अपने को सुरक्षित किया ही। दुनिया से 118 देशों को भारत ने एक नहीं 2-2 वैक्सीन दी। यह है भारत की ताकत। और भारत की ताकत आज दुनिया लोहा मान रही है। अभी पिछले 3 दिन से हम सब एरो इंडिया के भव्य, कहते हैं ना, जो दिखता है वो बिकता है। मैंने कहा ना कि लोग कहते हैं अनपढ़ों का देश है। ये अनपढ़ों का देश नहीं है, ये स्टार्टअप, ये इनोवेशन, ये टेक्नोलॉजी और ये हुनरों का देश है। दुनिया देखती रह गई, हमने चंद्रमा पे चंद्रयान उतार दिया। दुनिया बोलती रहे अनपढ़, दुनिया का सबसे डिजिटल पेमेंट करने वाला देश भारत बन गया। आज आपके बीच में आकर मुझे खुशी है। मैं पूरे कोस्ट गार्ड परिवार को मैं अलग नहीं समझता। तीनों सर्विसेज हैं, लेकिन उस तीनों सर्विसेज में एक सर्विसेज है कोस्ट गार्ड। खुशी से कम नहीं, न जज्बे में कम, मां भारती की सेवा में कोई कमी नहीं, देश की सुरक्षा, तभी देशवासियों का आत्मविश्वास बढ़ा आप पर। मैं ज्यादा समय नहीं लेते कि मेरी अभी फ्लाइट है, मैं आपसे बहुत बात करना चाहता था, किंतु मेरी तरफ से जहां देश के प्रधानमंत्री नरेंद्र मोदी जी का संकल्प और दूसरी ओर हमारे रक्षा मंत्री आदरणीय राजनाथ सिंह जी के नेतृत्व में हम बहुत तेजी से आगे बढ़ रहे हैं, और मैं चाहता हूं कि उस संकल्प पे आपका पहला संकल्प 2030 और 2047 के लिए ब्रांड एम्बेसडर, आप सब ब्रांड एम्बेसडर हो। 140 करोड़ देशवासी ब्रांड एम्बेसडर होंगे, क्योंकि 2047 दुनिया का सर्वश्रेष्ठ राष्ट्र, आने वाली जनरेशन को, आने वाली पीढ़ी को हम वह सर्वश्रेष्ठ राष्ट्र देना चाहते हैं। मेरा ये आपसे आग्रह है, आइए हम सब उस संकल्प को पूरा करें। पुनः आप सबको धन्यवाद देते हुए बहुत बहुत धन्यवाद। जय हिंद।
Thank you, sir. Your words have added a valuable dimension to our event, and we are sure that it will continue to influence and guide us in future. Now, I would request Additional Director General A.K. Harbola, President Tatrakshak Medal, Coast Guard Commander Western Seaboard, to kindly present a token of remembrance to Shri Sanjay Seth, esteemed Raksha Rajya Mantri. Thank you, sir. Ladies and gentlemen, we take this moment to express our sincere gratitude to Honorable Raksha Rajya Mantri for gracing the seminar with his esteemed presence. We understand your demanding schedule and sincerely appreciate the valuable time you have spent with us. Thank you, sir, once again for your invaluable presence. I request all the panelists and speakers to come up on the stage for a group photography. Thank you, sir.
Something else was there? Yeah, some of this. All yours.
Ladies and gentlemen, we shall now proceed with the session. I request the panelists to please occupy the seats on the stage.
So, back to business. So, after listening the inspiring words from the Honorable Rajya Raksha Mantri, I think it motivates all of us that whatever hard work we are doing it is being recognized. And in addition to it, I think we rededicate ourselves for the service of the nation. And we can't serve in a right fashion altogether if we don't have the expertise in the terms of the scientists, the academia, and the industries. So whatever our services are being acknowledged, I'm sure the services of each one of you are sitting out here, and the respective community is very much there. So anyway, I was talking about the R&D. R&D is supposed to be the is the engine of indigenization. And for prospering, for having an R&D, you need to have budget. And this year, thankfully, the government has allocated exclusive amount of the budget, especially for, like around 500 crores for setting up artificial intelligence place for excellence. So things are moving with the technology. And in addition to it, NRF, that is National Research Foundation, so the National Research Foundation has got 50,000 crore rupees in order to ensure that it reaches to the right place altogether. So I was talking about it, the beauty of our nation is what that since 2018 when this voice was floated that we need to have indigenized in 6 years of the time. We have got, our own radar. You have already listened to Dr. Rajesh. The kind of a development what they have done, it is immense. And the lady behind all these development is thankfully amidst us. At that point of time, she was heading the CAPS. I had an opportunity to visit the facility, and I could see that whatever has spoken about it is working in lab. And it is a state-of-the-art technology. The radar, what CAPS have manufactured is still not fitted in our Donias. And that is ISA radar. They've got their own EOIR report. These systems are being developed for our latest acquisition, which is Charlie 295, C295, that is called as MMA, or the Navy call it as NMR, MR. So, let's go to Dr. Menon and ask her that how in this short period of the time we have reached to a stage where the state of the art of the radar is available, at least at the in the laboratory, and time is not far. Then I'm sure that the moment any platform is given it to you, it is a matter of time that it's going to be flying in the air itself. So I just want to know, madam, no terrain is easier, and especially which I have spoken about it, that what the RRM has spoken about, a kind of image what country had. So we'd love to listen to you that how this terrain was and what kind of impediments you encountered besides the budget part, and how did you overcome. And with your, I think, wisdom words, everybody will be enlightened towards you.
So thank you for the opportunity, and without spending any much time, I will just try to answer the question. See, actually, first thing is for any indigenization or indigenous system development, opportunity is the first thing that is required. And I think we got the opportunity through the first program of AEWNC, what we developed and delivered. And once it was in that state, we got further opportunities, and Coast Guard was very, I should say, they understood the potential of the capabilities that is indigenously available within DRDO and approached us for AAMA. So the first impediment I would like to say is that time it was in 2013 when you approached us, and today we are, AON has accorded, and we are still waiting for the sanctioned. We have the process and we have to do that. But I think if that time can be cut short, it is one of the impediment that we can remove. I think I'm sure the processes are in place, and in the next revision of DAP 2020, there will be certainly some improvements done so that. Second aspect is, you asked how did this happen in 6 years. I will fully credit the whole thing to the team because they have the dedication and the passion, and it is only with that that we can have successes in indigenous. Coming to say about indigenous, there are multiple levels. One is indigenization, starting from scratch, ab initio development of a system. So that is what we are now talking about MMA, MRMR, which is a ab initio development. Even though we did do some technology development. So that is another success step that we can take up. That is, before we take up any major program, have it as a technology demonstrator, get what the user wants, develop it, prove it, and then go for the system. So we already would have developed the current what we had when we have started, but when the program gets sanctioned, we are in a stage to give a better program. So that is what literally today's talk Dr. Rajesh mentioned. And technologies are really many that is available. And next reason why we could give this is because we want our users to get the best or the better than the best, because always the user has the opportunity to go and import. Okay, but only if we give better than the best that they will come back to India. So that technologies development and newer technologies which will actually not become obsolete so soon, and which will give the capabilities which is better than what the adversaries has or the situation demands. So that is another aspect. Next is, again, we have to, we cannot say that we can develop any such system of, such complex system of systems alone. It is only with very, full ecosystem, defense ecosystem of the country has to really be part of it, starting from the academics. And you have got the right mixture here, I will say. The academics, the R&D institutes, the user who has to give the requirements. Because if we capture the requirements correctly, I think well begun is half done. That is what is the key. And use of a very good system engineering approach to see that what the user requires, is it being met by the system. So a good systematic system engineering approach will ensure that the system gets developed. The radar part, because as he had already, Dr. Rajesh has already covered in his talk, I think the aim was to see low swap, size, weight, volume and power radar on the aircraft so that you get better capability and more endurance. So that was the passion with which this system was developed. Whatever he talked about, the technologies to go to RF SoC, so that directly from RF level you're digitizing it and then processing it, which means many other modules you have removed, so weight is reduced. Cooling, now it is an air-cooled system. Otherwise it would have been a liquid-cooled. The weight would have been again more. So all old technologies have been slowly fading out and new technologies have been brought in so that when the user gets the system, it is better than the best. And another aspect is I think, I'm sure academics also will be covering, it is on the, the quality of manpower that has to be having. So there are many new technologies that is available which is being taught in different academic institutions. So all those also add, and when they join us, they are able to give their bit and see that latest technologies are coming up. And our endeavor is also to see if any of the imported system is available now, we would like to indigenize it. And towards that, there are many ways. Not only that, because if the industries have to further sustain, they also need to have more orders, which only can come through export. So we have very good opportunities, and we have in our audience some of the partners who have actually given us that opportunity too. So it is end-to-end from requirements, from the design, the industry partnership for development, And then finally what comes is, we have not gone to the stage of using it with the user Coast Guard. The flight testing of all these systems is a very, very challenging thing, especially when it comes to airborne systems. And that is an art by itself. And we have gone through that phase with Indian Air Force in our previous program. So the time is very ripe, because its Atmanirbhar Bharat campaign has really given a big push to each and everyone. So from manufacturing, we would like to say that it should be, Make in India should be truly reflecting Innovate in India for the world. I think that should be the key with which we can progress further. Thank you.
Thank you, ma'am. We appreciate whatever efforts you are investing. As a user, our job is to give you challenges to keep our country safe and secure. See the very dynamic situation, and you know the technology is actually pacing with time. Another part of our ecosystem is the academician, and we are great to have Professor with us. I will just quote you one example, Professor H.S. Mukunda, the gentleman who was heading combustion gasification and the department. So one of my colleague, he went to him and he said that I want to do dissertation under you. Professor Mukunda, he's a grand man, he's written a small book called On Combustion, where he started with the matchstick, that how the matchstick burns, and he's gone to the LPR also, liquid propellant rocket, in a small book. So he said, just go to HL, pick up any 6 problems, 5 to 6 problems, and we'll sort it out during this short duration of the 6 months. So that's the power of the academician here. I was reading an article published by All India Survey of Higher Education. So they say that there are approximately 40,000 colleges, 993 universities which is existing here in our country, 7,888 research institute, out of which 66% of 7,888 are with the private players. I just, what the initial point was, that what Professor Mukunda has said. So if our professors in the academy start picking up these issues and try to give the issues to their PhD scholars for the dissertation, and I'm sure with this kind of an attitude, the pace of progress will be much faster. Sitting on a premier institute, I would love to know that where exactly is the hindrance, where the industrial problem can be taken into your laboratory of the professors, so that it can be resolved, or how can be spurred up, how can be paced.
Very good evening to very good evening to everyone. You put a right question in front of us. The challenge comes in the basic science addressing the issues that what is being present across. But science has never been recognized. It's like Brahma, right? We don't have a temple for Brahma. But we have a temple for the science which has been sustained. So there is a gap, if you see, from the foundational science to translational for production. That valley of death, we call it in Western world, right? The TRL level from 3 to 9. The valley of death is where we have a problem. We need to resolve. We need to upgrade our existing infrastructures to enable the translation of foundational sciences to a product. So what I see is, in indigenization, we have a collaborative mechanisms to take care of these problems to solve. But what is missing, or what may be added to increase the efficiency, is public-private partnership in translational aspect, right? That's more important. Active public-private partnership. I just, reinforcing that. The reason is, when the translation happens from science to a technology, the day technology bonds, it dies. We need a sustenance of the technology in modification and adaptation, what she was mentioning, the cooling system that is changing and the reducing and you keep improving. The sustenance is what we really need. You want to enable the sustenance, you need a partnership from the beginning. Private companies to be part of the process in the beginning. I'm not saying that it's not there. We need to accelerate it, right? If you look at the future of indigenization, we have innovation, but we need to sustain the innovation to accelerate and scale. So that is where I'm just saying this partnership. The other aspect Dr. Menon pointed out, this complexity in testing infrastructure comes into picture. We need to upgrade. Maybe I just thought, I just give a different dimension to the question that you have posed. If you ask me, I would probably say I'm looking at indigenization something different. Indigenization is not a mission for us. It is our responsibility, isn't it? If you don't have our responsibility, we can't take care of our future generations. So we need to secure that technology, what we are looking for future, which means we have to invest today, right? So that's the thing that we need to look at it. This more of policy adaptation to accelerate, right? Innovate, sustain, and accelerate. That is what we really need. Maybe we need to look at something like sustainable indigenization, because we started this indigenization in the past 8-9 years, but we need to sustain this indigenization to have robust ecosystem, right? We have academia. Academia has another, responsibility. You pointed out the aspect. We have so many institutions being present, but the scale at which the interruptive technology that is coming in, the way we do business today, it is completely changed. The way we order food is completely changed. So the disruptive technology requires different scaling, right? So we need to really look at that aspect of it, a skilled manpower. See, as an academician, I need to talk from the point of view of what my colleagues in the research laboratory and my colleagues who are sitting here on industry will be looking for. How do I complement the future skill labors, right? We need to have a centralized mechanism to produce this future skilled labor who can innovate, right? So this is what is the thing we need to look at from our point of view to take it to sustained indigenization and to get an ecosystem where we invest on kind of a technology innovation center where user being also be present, right? User is a key. We need to give innovations to this problems or future problems that will be present, right? We never anticipated the kind of AI and drone technology today or sensing technology today will disrupt the way that we do maritime surveillance, isn't it? The large language models being in, talk of the town. Now ChatGPT is gone and our counterpart is coming up with solutions. Isn't it important for us to look at what we will be having in the future and invest on that skills required so that industry can sustain and accelerate? Maybe that is the gap I see it with all these institutions. We need to come up with a robust ecosystem for this indigenization to sustain.
So talking about the robust system, we are doing our part. We have just brought HAL just near to your door. We had a vibrations issues in one of a machine, and now Professor Manoranjan Roy has been, I think our MOU has already been signed, and that's totally from us. This was a pressure that here you got an expertise available next door to you within Bangalore, and I think Professor Manoj Ranjan Roy is now handling this issue. And ISC has got a legacy. Professor Munjal, he was a man who was working in the industrial noise control. That gentleman once in a class, he was talking about it, that central hall of Darbar hall of the Rashtrapati Bhavan, they had a lot of eco issues. So they approached to Professor Munjal that can you arrest this problem? Just to tell you the Professor Munjal's status, that the whatever law we have got in our country, that, for example, if we are neighbors and I have got a party in my house, and suddenly, the neighbor of mine does not like my face. So he goes to the local police chowki and tells him that Taha's house is creating noise and it is disturbing me. The law is existing, the law which is existing in our country. Policeman will come to, first of all, to the complainer and pick up the decibel level, and subsequently come down to my house and tell him, shut up, go back to the house, and again pick up the decibel level. If the difference of the decibel is 10, then the other guy is gone. If it is more than 10 decibel, then I am gone. That's the second issue, that how many places of the police chowki will get a decibel meter to measure the noise. So anyway, Professor Munjal has gone to Darbar Hall and picked up the decibel level and arrested it, and that's how we see nowadays wherever the Arjun Awards, etc. is giving, there's no issues altogether. Here, I think what we require to do is that if there is an ecosystem which is existing, expertise available, the only thing required is the connection. And this connection, who best can we do it other than the user, because we are the one who are getting affected. And if we have got a close collaboration with each and every person and trying to have some kind of a forum where we can eat, we can talk, like if you see from HL, different divisions of HL, they sit together once in quarter, I think, where the CMD is heading some issue and they're talking about it, what's going on. If similar kind of an ecosystem is existing between academicians, the scientists as well as the industries, I think we can move in this direction itself. Time, sorry, it's running out. So let me go to Paltasar. He has got a mountain of experience. Presently, he's a chief advisor to the many. I've got a question to you. There is a common saying which is prevailing in our society as of now, that you should never chase the technology. You should be you should always be a leader of the technology. Madam, when he has given its open the remarks, that was also one of the sentence. Another CDS, whenever he gives a presentation, he talks about it this. So now we've got a two option. One is to get your solutions, you have a technology transfer, or you develop it on your own. So if you're following a philosophy of technological transfer, then you are trying to follow the technology. But if you develop on your own, then you are maybe like, you have seen the ASA radar where Dr. Rajesh was talking about it. Now we have gone to the radar, which is software driven. So in the similar fashion, we can be a technological leader. So as an advisor, somebody approaches you for a specific query, should I go for the TOT or should I go for, my developing our own technology? What is how you measure this particular, how you decide that it's better to go to TOT or it is better to have our own development?
I think this is a very... Am I audible? Very interesting question, because fortunately I have the advantage, as when the introduction was being done, I had a great learning with HAL for almost 4 decades. And now I have been in the private sector for almost 1.5 decades. So I have seen both sides of the picture. When I was in HAL, and today also it's the same stance, we would like to be ahead of technology, not chasing it. There have been instances, even today it is happening, where HAL does programs where it takes TOT. But lot often it's trying to be ahead of technology. But timeline is the most important thing, because for the services, it's, what is the operational need? Do I need it tomorrow, or do I have the leisure of waiting for a couple of years? So there'll be different technologies. I will give an example which happened with me when I was heading one of the HAL units. We were looking for a TOT with a foreign partner, and it was almost into final stages, but then we realized that there was not a complete technology transfer. So we were asked to present the case. This was in case of an Air Force system,
and we went to make the presentation. At that time, the vice chief, he caught on to the nuances, and the, the very interesting part was, he saw the first 2 slides. He said, Mr. Palta, can you please present me the last slide? And the last slide, in all our systems, in the services, in the DPSUs, in the DRDO, we all know in the end we will put the executive summary. So the executive summary was that we were getting 30% TOT and 70% the content was with the OEM. So he said, I do not want this because it doesn't serve my purpose. I want an indigenous system. Fortunately, because my team had, we had all brainstormed that this definitely is not acceptable to us and our customer is not going to accept it. So we had gone prepared with some homework, how much time it will take to develop an indigenous system. So he asked the question and my team answered that we'll take about 2 to 2.5 years to develop an indigenous system. He said, fine, I'll give you 3.5 years. And he said, you're all well aware of the term, reduce to produce, stop purchases. I will suffer some lower serviceability in the fleet, but produce it indigenously. So we, not chasing the technology, we went ahead of it, and afterwards I moved out, but the division did it in less than 3 years.
Wow.
Now, coming to the private sector, I think it's totally a different ball game. The first thing which I learned was, I joined the private sector in 2008, immediately after my retirement, but I learned one lesson which lingered on in my mind, that the stakeholders do not have patience to wait far beyond, say, 2 to 2.5 years. Maximum is 3 years, which all of us face when we are, interacting with the private sector industry. Because there are promoters, there are investors, there are bankers. They would not like to wait for 7, 8 years or 10 years to have their returns. And my first exposure was one of the very big private sector company. They were wanting to set up their aerospace business in the year 2001. So a common friend said, why don't you come and have a discussion, how they can go about it, and maybe, they seek your guidance. So I said, fine, if private sector is wanting to set it up, I don't mind having a discussion. So they had the complete board there, the technical board, and they said, after a couple of questions, in how many years our aerospace business can start giving results? I said, I can't say straight away because you have to first define what is your aspiration, what kind of product lines you want to go, you want to make an aircraft or systems or whatever. But broadly, I'll tell you that it will be anything from 8 to 10 years. And one of the gentlemen said, you must be joking. I said, no, I'm serious. 8 to 10 years? He said, what I said earlier, beyond 2.5 years, if I tell my board, the other board members, they will just throw me out of the boardroom. And of course, I had a very long discussion. It went on till the evening with the chairman. I said the same things to them, but eventually they never went seriously into aerospace. This, over the years, I have experienced the same thing. When I came to my present company, the Mani Group, I was asked to set up the aerospace business unit. So keeping those lessons in mind, whatever I have picked up on the way, I talked to some of my colleagues because I was asked to present a paper on the way forward in the next couple of years. And since I knew the nuances, I kept it for 3 to 5 years so that, people, we had some foreign investment also. They are comfortable with what I'm presenting. And after all the things that I had detailed, this will happen in 1 year investment, 2nd year investment, 3rd year, this is what we will start making, and all those things. A question was asked to me, Mr. Palta, you are not presented what will be the return on per square foot floor area. Now this, many of us, my friend Mr. Bhatt is here from HAL, another friend, and many would be in the audience also who are from the defense PSUs or in the government organizations, and I don't know whether Dr. Menon would have ever looked at per square foot returns on any project. Fortunately, there was a youngster who came and told me, sir, beware, when you're making the presentation, you have to present this. So I had it, as a trump card, I presented that. Why I narrated this is the kind of returns in the private sector the stakeholders are looking at. Now come to the indigenization part of it. I am a part of the Society of Indian Aerospace Technologies and Industry, CIT. So I have had the good fortune of interacting with industry, larger ones who are our members, MSMEs, medium-sized enterprises, which are maybe slightly above MSME levels. Everybody has the same issue. People invest on their own. They are not able to give returns to their promoters or the promoter themselves. If it is a very small organization, it becomes a challenge. And that is where is coming the way, because lot often, or by I should say lot often, for example, the avenues which are available, one is Technology Development Fund, but it is only on specific cases where the users, like the services, have a problem statement. Other cases, even if there is a product to be developed, we are asked, now I am talking as a private industry person, we are asked to put in our own money. If I have to put in my own money in a research and development, I will not be able to, using Professor Sundaram's word, sustainability. The financial sustainability, the stakeholders will throw out people who present that case.
Sir, absolutely right. I think I just got a point here, which I have discussed in different forums altogether. As you know, the money is one of the prime thing which is required to be moved around. I'm talking about our case. Our budget is of the order of 700 crores. And 90% of the budget goes to the PSUs, that is the HAL. So I've sent across a proposal to in a particular forum. Like, when you started paying the income tax, they said 10% your cess part. So my proposal was that for R&D fund, if you are paying, for example, 1 crore for a particular RMSO, you can have 0.1%, 0.2%, which is a piddly amount when you compare it from that responsible. So something is required to be done in such case, so that at least there is a fund. Now the talk which is going on in the present world, that now private players are supposed to come in, because as of now, till date, it's public money which was being pumped into the R&D. And now that depends on, like, in case if you are at Tata's or Birla's or the Ambani's or the similar Reliance, etc., you got a money to pump in. But for a small scale industry, I think there should be a collegium road where everybody is giving, kind of a EMI part, and then having a amount, and then common things can be undertaken. Now I think time is short, so I'll just go to Mr. Bhatt, just to tell you that he's coming from a division which has developed around 15,000 items which has been indigenized. Am I right? Yes. And in a matter of 2.5 years. So here is an example which says that where there is a will, there is a way. It also tells us that country has got the resources. Either we are not aware about it, or we don't know how to channelize our resources. Another example of the TADA Kanpur, the Dornier, I think they have identified 206 items which are required to be, the COP is sitting out here, please correct me if I'm wrong. So 206 items they have identified, and out of which, in the previous financial year, they've completed around 50 to 56, and the number now is, I think, 75 approximately. So with this kind of a pace, it's not a time where, we can say that Dornier has become purely indigenized. I would love to listen to Mr. Bhatt and the other, in case if I don't know how many private players are existing here, that with your experience, that how did you arrive in such a short duration, hardly 2.5 years, and then you have crossed the number of 15,000 items. I'm sure you will talk in a poetic language.
First of all, thank you very much, sir, for giving me an opportunity to be a part of this August gathering, where we have got on the same page the academia, the R&D, the private sector, and the forces and the DPSUs. We at HAL have what we call a simple language. We have taken the bull by horn. It was 2018-2019 when the mission of Atmanirbhar Bharat came from none other than our beloved Prime Minister and Ministry of Defense. And the DPSUs were tasked that we have to go for this Atmanirbhar Bharat mission in a big way and do it too on a fast track with the timelines duly mentioned. And for that, HAL has taken a lead role among all the DPSUs. And right from the whatever, any big thing, if it has to be, it has to be the top driven. So the word indigenization, which has been the buzzword, and it is not a bubble, it is going there to stay for a long. And the mission was given to all the divisions. In 2018-19, all the divisions, we had indigenization departments as a subset of the R&D centers. We have got something around 10 R&D centers dedicatedly doing the ab initio design, and the indigenization departments were a subset. They were doing a little bit of indigenization as a part of FE and MOU parameters. But it was 2018-19 when that mission came, and all the divisions had been tasked to revitalize their own indigenization departments. And at the corporate office also, the indigenization department was strengthened. Adequate manpower along with the best of the officers were pulled in from all the divisions and pumped into the indigenization departments. And on the same page, we have categorized the items on the basis of the categorization has been done based on whether the items are electronic items, the electrical items, PCBs, ICs, or they are the purely mechanical items, or they are the materials. So categorization of the items we have done, we went for the purpose of indigenization in a systematic and focused manner. We categorize the items based on their material aspects, based on their configurational criticality, flight safety, and LRU indigenization we took on one hand, and at the same page, since we are catering to all the platforms, right from the fixed wing aircrafts to the rotary aircrafts, there's a huge chunk of spares which go into the build-up of the aggregates as for the MRO as well as the manufacturing aircrafts. And these spares, believe me, it was into thousands of crores that was going for foreign exchange to the outside world, beyond the boundaries of the Indian borders. And then we took up the spare indigenization. Then again, the one thing was that we cannot do everything in-house. So we took a sustained efforts to bring in our private partners on board. And we have done conclaves, and month-wise, you can believe, month-wise conclaves are being held either at Kanpur, Korba, Lucknow, Hyderabad, and even in Bangalore. And these conclaves, we do the category-wise. Once we do for example, only on the electronic side, we do conclaves, then the mechanical LRUs. Same way, the materials we have been doing the conclave. And when we started in 2020, even the Air Force was of the opinion, some things are beyond the control of, or beyond our comprehension that we can indigenize. That is the bearings, aircraft bearings, that goes into the build-up of LRUs and aircraft. That was a taboo point. So when we started the first conclave, then I told, let us really catch the bull by horn, and we started the first conclave on the bearings. And we roped in some around 8 to 10 vendors from the Indian private industry, and we have got CVRDC and Jaipur College of Engineering also, precision bearings also. And they came along with us, did a one-day brainstorming, and ultimately after 2 years of hard toil, we had been able to rope in and put the purchase order on private industry for the indigenization of bearings.
We really appreciate your efforts. And as first of all, let me correct it, the 700 crores what budget I said, it is purely on the aviation, not for the entire coast.
That is what HAL...
So my point...
One thing I want to add, this fund, basically there was no fund for the indigenization per se. But HAL corporate has taken a decision that 3% of our profits every year will be allocated for the indigenization purpose.
Fantastic.
And right now, around 1,000 crores has been given to the various divisions of HAL for the purpose of indigenization. We have roped in the industry. We have got seat in IISc Bangalore. We have roped in IIT Chennai. We have roped in IIT Kanpur to be a part of the indigenization process of HAL. And materials also we have taken, I think you might be aware that the mandate has come from the government of India that jet engine indigenization has to be done. That is on par with the AL-31FP engine. And material indigenization is one area where we had the constraints, but as of date, every stakeholder, right from the private industry to Midani to DRDO to HAL, we have come on board and we have mapped up the roadmap. Around 8 to 10 years, it will be a ground reality that 90% of the AL-31FP engine will be indigenized within the country.
Yeah,
and that's a great news for all of us.
That's what the collaboration is required, and I'm sure if we are moving in the right direction, it's not intentionally.
And I will take the opportunity of this forum, just we have our private industry partners might be also here. And I request them, the youngsters, to go for this, the buzzword indigenization. We can collaborate, we can innovate, and then we can lead the world. The disruptive innovation, it should not be on innovation. You should go for the disruptive innovation, which is the buzzword. You should have the passion to go for the innovation. And definitely, as Mr. Palta has rightly said, we should wait for the fruits to come. So it will take 3 to 5 years for indigenization of LRUs, but there's a long way to go for the return on investment. It is going for years to come for the return on the investment. Have the patience, be a part of the process of indigenization along with HAL and other defense forces and the DPSUs in particular. Thank you very much, sir, for giving an opportunity on this forum.
So we commit, and we have been doing it, that whatever you are indigenizing, what we can do is we can offer our aircraft for the NCNC trials, subject to it has been certified this CEMILAC. The point here is that indigenization is really pacing with time, but we should always remember the life is very important. It is not a ship. Aircraft has to go in air. The quality is not to be and never to be compromised. Just to conclude now, the indigenization actually is giving two important F's to us. First and the foremost part is the forex, we are saying our foreign exchange, which is paramount. And number two, which is equally important, it gives us freedom to operate. So just imagine a situation, a bird sitting on a branch does not fear to take off, even if the branch is cut. We presume or we assume that our mechanical birds sitting on a tarmac should also fly whenever there is a requirement without any impediments. That is what the real indigenization is. On behalf of the ICG community, we wish you, the scientists, the academician, to the industries, to the best of luck, and thank you so very much for being with us. Thank you. Vayam Rakshama. Jai Hind.
Moving on to the felicitation ceremony, we would now be felicitating the panelists. I would request Deputy Inspector General Jamal Taha to kindly present a token of gratitude to our panelists. Dr. K. Rajalakshmi Menon.
Thank you so very much, ma'am, for your time. I'm going to be occupied. Sorry. This is important.
Professor Suresh Sundaram. Professor Suresh Sundaram. Shri Kaval Krishan Bhatt. Dr. Naresh Palta.
Thank you, sir.
I would request Coast Guard Commander Western Seaboard to please come up on the stage to felicitate the moderator. Thank you, sir. I would request the Coast Guard Commander for a group photography with the moderator and panelists. Now, I request Additional Director General Anil Kumar Harbola, President Tatrakshak Middle, Coast Guard Commander Western Seaboard, to deliver the closing remarks. I request Coast Guard Commander Western Seaboard to deliver the closing remarks.
Good evening, everybody. On the lighter side, I happen to be somebody from Uttarakhand, and I'm very fond of tea. So standing after a long session of discussions and very intellectually inclined presentations, and the hot tea which is waiting outside, I would not like to, linger it more, so that, I'll keep it short. Dr. Raja Lakshmi Menon, DG Aero, DRDO, IG Shashi, Commander Coast Guard Northwest, my colleagues from Indian Coast Guard, my distinguished speakers, panelists, and my friends from foreign as well as media people. I would like to give you a user's perspective in a layman's language, not going very hi-fi, because all the job of being, talking technology and other high things has already been finished. And my compliments to everybody. I think when I go out from this place, I'm much more learned and educated on all these issues. Particularly to my foreign friends, I would like to say that we are very proud to have our association with HAL. And our record of flight safety in Dornier flying, I'm being very specific, in Dornier flying has been excellent. Touch wood, in last around 47 years of our flying record, we have been absolutely exceptionally safe. Maybe some minor issues here and there. So if any of you are planning to acquire these aircraft, particularly after it has been upgraded, I'll be somebody who will be supporting your thoughts. My also compliments to Dr. Menon and her team for looking into the future as far as our MMM aircraft is concerned, and catering for the technology we require maybe after 6 or 7 years from now. Though this complete project is also delayed by time, we should have had our MMM aircraft maybe around 8 years back. But as I was discussing, sitting there also with Mrs. Dr. Menon, that, we as a user, I have some problems, I need the solutions. I'm neither industry, I'm nor academicians, nor a research scholar. The solutions are with you. I can only project my problems to you. And as we do in the services, we say, do it beg, borrow, steal. Excuse me for saying so, it is not in literary terms. You do whatever you want to do. We need the solutions. PPP, transfer of technology, import, export, whatever. We need the solutions for our problem. So that is the user's perspective I would like to give. And timeline is the biggest issue. If you give me a liberty of, when do I need the solutions, I would say yesterday, not even today. So that is what I look forward for all these panelists, speakers, guests, that we need the solutions, problems are known to us. You also think the problems which you are going to face. Yes, along with the timeline, in my experience in the service, regulatory support is also an issue which we are working on. There are a lot of changes, major changes are coming up. As one of the presenter, I think Dr. Omkar, he mentioned unmanned vehicles. Even if we find tomorrow, these vehicles, these instruments are involved in some anti-national activities, anti-law, unlawful activities, do we really have the support of a regulatory framework? That is something also which is there, and it is in my mind also. So my request to everybody involved is squeeze the timelines, give us the solutions. We don't have the dearth of money. DDG Aviation might have a different opinion, but I don't think we have any dearth of money in Coast Guard. We are ready to pump in as much as money as Honorable RRM also said. Our budget is also gone 27% higher, and we are about 5,000 crores of rupees on a capital budget. So I don't think we have any dearth of money. It's only the will, and we are ready to pump in anything. We welcome NCNC trials in our platforms, whether it is aerial platforms, whether it is surface platforms. So with this, I will like to conclude my address here. But before I do that, my compliments to DIG Taha, who has steered all these arrangements and seminars. My compliments to all the participants. My compliments to DIG Shrikant, the team CGAOT, and all other officers who have been deputed from different Coast Guard locations to this place. And we assure you that as a service, a little correction in between before I finally wind it up. Coastline of India is around 11,098 kilometers, not 7,500 kilometers, used to be earlier. Coast Guard per se may not be a guarding force, because the area which we safeguard against the anti-national or unlawful activities, the domain, maritime domain, is not only anti-national activists are there. It is an area where your adversaries are present, your anti-national elements are present, your unlawful people are present. So it is very, very fluid situation. We cannot be termed only as a law enforcement agency. We have much more to justify our presence. And in some of the major countries all over the world, we are the 4th largest Coast Guard in the world. And that is why, US Coast Guard has nominated its Coast Guard as one of the 5 streams or 6 streams they have in their military. So Coast Guard is something with very peculiar characteristics and very peculiar duties. But we assure that whatever the charter we have been given by our government, we will not leave any stone unturned in fulfilling. And I'm proud to say that as a reputation as an armed force of the federal government of India, I don't think we have found anywhere lacking in execution of our duties. Whatever comes, we will ensure that we do it, whatever task has been given to you. I'm proud of our organization. Like, any one of you, you are proud of your organizations. Thank you very much. Jai Hind, Vayam Rakshamaha.
Thank you, sir. So now I request all the speakers and dignitaries to please come up on the stage for a group photography.
Thank you, sir. Ladies and gentlemen, we kindly request the dignitaries and all the attendees to proceed to the refreshment area. Thank you.
Once again, we would like to extend a heartfelt thanks to the audience for their undivided attention. Please do not forget to collect the thoughtfully curated mementos as a token of remembrance and thanks from our side. Jai Hind, Vayam Rakshama.